Hello, hang on. Hello, I am the Ronan Pawn, and welcome to a twitch.tv/Ronan Pawn livestream on twitch.tv/Ronan Pawn. Have you ever watched someone on YouTube who's like they've got a channel, you know, it's not going to be that big because of what I'm about to tell you, but you know, they've got a channel, they've got some viewers, they're making a little bit of money kind of thing, and it's just really obvious that they have no idea what to do with their hands while they're talking? Have you ever seen somebody who's like, I've been told that I'm supposed to move my hands a lot to be expressive, but I don't know what, it's just completely unnatural to me, so I'm doing what they say to do, and I don't know what to do. Hello, I am the Ronan Paul. Welcome to the show. Welcome to the show. We do it twice a goddamn week over here. I can't believe I'm still going after all these. Welcome to the show. We would probably be doing some cluster chuck speedrunning today, except for last live stream we did a bit of The Farmer Was Replaced. A pretty new title to 1.0. Anyway, a newly 1.0'd title, in which you code in Python drones so that they farm your land for you. And I would like to start off this live stream, like this probably won't be the whole live stream, I would like to start off by going back to The Farmer Was Replaced and just like tightening up some of that code, because I watched back the last stream, I was interested, and I don't usually watch my streams back necessarily, but the code and stuff, I wanted to see what I had done, and I felt it was good, like tutorialization. We wrote in long form, that sort of a thing. I get to the end of it, I have the desire, I have the internal need, the craving to return to the code and try and optimize it and extract most of the potential that's left there. That doesn't mean that we're going to keep playing the game and digging deeper and deeper into The Farmer Was Replaced on the live stream here necessarily. But I do want to go back in and do some things, including I would like to introduce you to Bresenham's Raster algorithm. Huh? Now you rock hard instantly. I say Bresenham's algorithm, and you're like, oh, tell me more. Nipples erect. So let's talk about Bresenham's Raster. Let's get into the game, and I'll introduce you to Bresenham. Bresenham, Jack E. Bresenham, in 1962, formalized a algorithm, a very, very simple, very easy algorithm that we'll still have to look up regardless of how simple and easy it's supposed to be. I won't. Oh, we've got some new hats in, I believe. We gotta check in on what kind of hats that I got, because I earned some that I didn't notice during the last live stream, and it just told me that I got another one that's like trees.hat. 420 blaze trees.hat. I hope it's smoking a little bit. This is our farm, okay? This is our farm as of the last live stream. We unlocked a 12 by 12 grid, and this is how we farm in our farm. Our farms like this. We created, we're using multiple different files, we're importing different code, we're using, we've got everything functionized, and we're using a series of functions that we cooked up that allow us to arbitrarily declare an area of the farm that we want to grow a certain crop on, and we just tell it, the size of the area, where the area starts in the lower left, and that's that. And so what we've done is we've split our fields into, half of it is pumpkins, but they're broken up into 6x6s. It appeared from the documentation that 6x6s was the largest that you could get, and that is precisely the reason right there that we've done it this way, is because the pumpkins, when you fill the entire area of your pumpkin patch with live pumpkins, they combine into a larger pumpkin, as large as they possibly can. You see it happening right there live, as we're making them. So when you get way more pumpkins by growing a giant pumpkin than if you were to just pop them, you know, with whatever happens to come in. So doing a 6x6 square, we get up to, you know, 2 6x6 guys, and the math on that, we can actually look it up. If I pull up the, maybe we zoom in a little bit. If I pull this up again, look at pumpkins, it tells us that a 5x5 pumpkin field, it's a patch, okay? Developers, a pumpkin field is a pumpkin patch. Thank you very much. Welcome to the farm. It says a 5x5 yields 5 times 5 times 5. So it's basically whatever the number is to the power of 3. But then it says here at 6, the number at and above 6 is n times 6. So it tops out at being the number squared times 6. So 2 6s should produce more than, like, you know, 1. I don't know, that's sort of, we could get into testing to see, like, what our yield is. And if we want to go ahead and just refresh ourselves on the code here, wouldn't hurt anything to do. This is our main code, and it's just our, you know, it just organizes things, and you can see how nicely we've functionized everything and packed it all into its own little concept there. We've got, while true, a infinite loop going, where we just say plant an area of pumpkins at 0, 0 that is 6x6 large, and true means require that absolutely every single pumpkin has come in before you harvest any pumpkin. That's how our function works. So plant pumpkins at 0, 0 in a, you know, 6x6, plant some wood at 0, 6 in 6x6, plant none, which is hay, and here's like one of the first things that we could actually improve, and the way that I've been making improvements in the code is I make a new one to store the old code so that we don't interrupt the program running while we're making, you know, new code. But really, like, crops should be, we should have hay. It's grass is what it is, but it looks like hay to me. So, I mean, that's what hay is it's old grass kind of a thing. But I mean, I don't know if the game ever uses the term hay. Does it? Maybe it does. I don't know. But define hay, pass. So that's what we should be doing here. Instead of passing none. And so now what I could do, and let's see if this works, this is my peer anyway, is I just copy paste that in, and then we go to here, and I say hey. Pass hey, start it back up. We've got an error. The imported module has a syntax error, crops import, right? So you pulled me to the wrong one. A code block must contain at least one statement. A statement can be a function. Do you need it down here? Because you're so, like, stingy about Python code. No? Alright. If you need me to do something in the thing instead of just using pass, then how about that? Return none. A code block must contain... Oh, I'm... Wait, no, okay, so I would need to fix it over here if that was going to solve it. Do you just need it below there? Is that your only real complaint? Yeah. See, you can actually do, you know, put it all on one line. You don't have to abide the PEP conventions of Python, for Python to run. So you can put def hate pass on a single line. Pass just means, in fact, if I hover it, does nothing. Can be useful because empty code blocks aren't allowed, as we saw. However, this you know, game also is dedicated to the PEP conventions, PEP, and they just define like the conventions of how you should code, and you know, how you should handle your white space, how many, you know, individual spaces should be in a tab, when and where you should or shouldn't use a one-liner, so to speak. They also set up rules that do, you know, apply in the language, for things like, well, see, Python doesn't have strict typing. The idea of strict typing is that, you don't just define a variable and then put anything in the variable. You define the variable and you say what the variable is. So what is it going to contain? And by doing that, it's way more efficient. The, you know, compiler, usually, when you've got a strict typed language, will now allocate exactly the amount of space that that type of variable needs, because it knows what it's going to need. Python doesn't do that. Python has one generic container, and then, you know, it just establishes a space when you establish a variable, and then when you put something into it, it snaps to, okay, this is what it stores. So it uses more memory, and it's slower because it's an interpretive language instead of a compiled language. But anyway, strict typing. Python doesn't do strict typing, but the Python PEP conventions do establish a styling format for practicing strict typing. And this is actually a very good and helpful thing, one for the legibility of your code, to be able to like look at something and see, okay, that's supposed to be an int, that's supposed to be a float, that's a boolean. But more so for the sake of an IDE, for a development environment, for the program that you code in. The more information that you give to that IDE about how the code is meant to be used and what sorts of variables are supposed to be coming in or going out here or there, the more the IDE can like catch your errors for you and say, hey, wait a second. A float just landed in this variable that I've been told is supposed to be an integer, and so it can be helpful to do that sort of thing. So the PEP conventions, you know, there's a lot going on in there, thousands of conventions, but you don't have to follow them, and some of them are stupid and bad and wrong. Including just like, and let's have this argument right now, since no one's here to argue against me, and that's how I like it. Snake case. Python is a snake case coding language, and what that means is when we define variables, when we define functions, when we define anything but a class, it is all lowercase. And whenever there are like two words or two concepts, we put a underscore in between them. That's what snake case is. Camel case is objectively better. Okay? If you use it right. And so what I do in my code, what I'm doing in my latest library that I'm working on, is I'm using a mixture of camel case and snake case so as to get the absolute most communicative convention out of it. What I do is, if it's a class, if you're making a class object, which if you don't know what that is, I'm not gonna explain it. If you're making a class, then that's always capitalized. But we're going to also do camel case there. Camel case is where if you have like a second word in your name, like Col Odd there, it would be lowercase COL and then capital O, lowercase dd, camel case, so the humps in the middle. You do a little capitalization whenever you get to a new word. So classes are capitalized camel case, functions are not capitalized camel case, and then variables are snake case. And so that's just the most communicative way that you could possibly do anything. You're giving as much information as you can possibly give in every line of code, so that if somebody walks up to something, they can immediately see that's a variable, that's a class, that's a function. Now, you can't tell when a function is a function by its camel case if the function name doesn't have two words in it, and there's no like hump in the middle for you to go, oh, they're using camel case, so that's a function. But that just puts you back to the scenario that you were in when you were just using snake case. So we have objectively made the situation better. We have improved the likelihood that you'll be able to detect and know when a function is a function. Now, you could argue most of the time you know that a function is a function because it's got parentheses at the end of it, it's being executed. But you're not always executing functions, sometimes you're passing them, as indeed we do right here. We define our crops, so I was going through a code review, and I've managed to tie it back to what we were doing, even though I just went on a tangent. Here, we define what our crops are, like what needs to happen to plant each of our crops. And with hay, we don't have to do anything. With a bush, we got to plant a bush. With a tree, we got to plant a tree. With wood, we got to decide whether or not to plant a bush or a tree, because trees don't want to be next to other trees. They will grow slower if they're packed in right next to another tree. With carrots, we just need to make sure that we're on the right kind of soil, and then we can plant the carrot, and same thing for pumpkins. But so that defines that. Over here, shut up about the error that isn't there anymore. Over here, we've got plant, crop, crop. And so when we call plant crop, we pass a function, like we're doing right here, pumpkins. We didn't put a parentheses at the end of that in order to indicate execute it because it's a function. So how do you know that that's a function? Well, you can't. But if we were using camel case, you still wouldn't be able to because they're all single words. Shit. But when there is a greater likelihood that you'll be able to tell that those are functions when you're using camel case. So that's my convention that I follow. It's snake and camel. I consider it to just be the best of all of them. So continuing with the code review, we've got, I don't like to look at the stuff that's flashing. I know that some people have problems with that. I have problems with that depending on what time of day it is. So let's not stare at the things that are flashing. And honestly, I think maybe there should be a mode, maybe there is a mode, for accessibility where the code highlights. Disable. Back in. Okay, there's no code highlights now, so if you have a problem with flashing, then it's good. I would like to still be able to track the code, though. So, you know, what I would suggest is using, like, another little column here, where you've got, like, a little cursor that moves with the code. And that's the indicator, instead of flashing lights and stuff like that. People, there's neurological conditions that you want to provide accessibility for. This does it. But I've also lost functionality because I have a disability. Is that fair? No. So let's another little column here where you can chase the code with a cursor is my premise. That only appears if you disable code highlighting. There you go. I solved it all for you. So we don't actually have to look at this now because we can look directly at the running code. So, code review. From crops, import. So we bring in all of the stuff that we've coded over here that defines what we do to plant our crops. And then we've got a couple of different methods. We've got a move to method, which simply you tell it where you want to go. Destination X, destination Y on the grid. It'll figure out where you are currently on the grid, and it'll figure out how it needs to move you in order to get you there. And that's where today we're going to bring in Bresenham. And 1962 is going to school us on how to travel in a line across a grid. Then we've got the plant crop method, which is kind of just a wrapper method. If the crop isn't none, then we run the crop code, and we could actually ditch that at this point because we're never passing none now. We always pass something to it, and I think that's better in kind of every way. Plant crop, and then we're requiring a crop to be passed, and then, but anyway, if there is no crop, right, if crop is not none, then you know, plant the crop. If we didn't tell it to plant anything, then we check to see if the ground type is equal to ground's soil, and we till it. This was a very little hacky way to handle hay. What did you don't do that. When the code is running, it still lifts the window above it, even if it's not flashing. So it pulls the window on top. Am I wrong in that? The UI here needs a little bit more work anyway. I keep running into stuff like that. I'm going to copy this over so we can leave that running. And actually, I'm going to need another one, aren't I? You're going to need another one. Give me you. Because what we're going to do, see, the improvement we're about to make, is I'm going to take this out of here. If get ground, soil, till, this is just to handle if when we go to plant hay. So we don't need to do that. We don't need to have that like in the plant crop function. Okay. This should be a thing that happens. Why are you so fucking indented, by the way? And what do you mean error? Fuck off. I'm in the middle of changing my code. Leave me alone. Can I make it, like, fuck off and leave me alone? Errors. You're both disabled. Oh, that's increment numbers effects. UI size, viewport, slide in. It doesn't look like I can make it fuck off with its error detection. That's really annoying. Like, I don't code in the same place all the time. Sometimes I jump around and... if crop is not equal to none else, we're no longer doing an else. So now plant crop just plants the goddamn crop, which makes it feel like maybe it just doesn't need to be there at all, right? It's an access method, it's a helper method. It allows us to, if we ever wanted to plant an individual crop, then we could plant it. So we'll leave it there. But, hay does not need to plant anything because on grassland soil, it will just instantly start growing. So all we need to do if we're trying to plant hay is check to see if it's the right kind of ground. And if it isn't, then we'll till it to change it into the right kind of ground. And other than that, it takes care of itself. So let's go ahead and... Well, actually, first, before I do that, let's wait to reap the benefits of our giant pumpkins, because it takes a while for them to come in. So one more pass on the giant pumpkins, and we can continue our code review while we're waiting. So that's plant crop. We're about to fix that. We're about to change things there. Plant area is the method that allows us to, define an arbitrary area of the terrain by width and height and say plant this particular crop there. Now you're gonna have to do a pass here and then here. You prick. Alright. Alright, you prick. One more, here we go. I'm waiting for it, Harvest. And then stop. I don't want you to waste my seeds. And so this is crops, right? No, this is this one. Harvest methods. And then this is this one. And then start her back up. And we'll see if I broke everything. Hopefully I didn't. Alright, back to the code review. I'm kind of actually... Let's wait to see that hay comes in correctly. Hay grows down here. When we get to hay, that's mainly what we just changed. Looks like it's fine. Alright, code review. So plant area allows us to plant in an arbitrary square anywhere around here. It takes in the start X, the start Y, width and height, and then we tell it whether or not to require that the entire crop is full and ready to harvest, which is a method that's specifically just for pumpkins, because the rules on pumpkins are, as I explained them already. I'm not going to repeat myself. I'm feeling already low. I'm winded. Nobody's listening to you, surely. So how do we get there? Well, for Y in range of height, new Y, start Y, for X in range. So basically we get ourselves into a nested loop here where we're defining the X and the Y coordinate that we need to move to, and then once we get there, wow, okay, so it's implicit. The original move is implicit. That's cool. So we figure out the X and Y coordinate that we need to move to. We move to it, and then if we can harvest, and we don't require that the, crops be full, then we go ahead and harvest it. And then, if the entity is something that we want to just plant on top of, whether there's nothing there, there's only grass there, or there's only a dead pumpkin there, then we do our plant crop bit. And if we planted a crop, then we mark ready false, because ready is what we use to indicate when it's time to yield a full fields, a full patches worth of crops if we require fulling. And then so after we do that, the last thing is we check to see if we're ready. We check if require full is true and ready is still true, which means that we went through an entire cycle without planting anything. If that happens, then again we iterate over the same y and x coordinates in order to move to the starting position, harvest, and plant the crop, which is what we see happening right over here right now, actually. The last little method that we've got is plant col, which was for planting in columns. We no longer use that. We could deprecate it, we could throw it away, but, just as with plant crop, it makes sense to keep them around. It makes sense to keep these methods around. Someday we might want to plant in a column again. And why run all of this code from plant area when we could run 5 lines of code to acquire a plant column instead of all this stuff to just, define an area that's just one strip. So that pretty much brings us up to date on where we left off last time. What I would like to do, I've already made one improvement, which is that I got our crops organized in a way that makes a bit more sense. On license stream, I need a split. I don't even have live split on screen. I need, welcome to the stream. So what I would like to do at this point is I'd like to introduce you to Bresenham's line algorithm. I came into awareness of this algorithm in working on my project. My current Python project where I'm making a graphic user interface system for Python, where I'm trying to get the most out of Python's own TK and photo image. And it's a horrible system. And I'm trying to make it usable as well as efficient and modern and pretty and able to look however you want it to look. So at one point in my code development, I was using Bresenham's formula. I'm no longer using it. I came up with better methods overall. I use a delta time animation thing where I was using Bresenham before, but I learned about it, so now I'm going to share it with you. So let's look it up. Let's pull up Bresenham's formula. What it is... Why are you full screen? What it is a line rastering algorithm, and it's incredibly simple and a little bit genius and entirely implementable in a little game like this. Bresenham's line algorithm. What it is consider this. You've got a grid. Okay? You got yourself a grid. It's broken up into X and Y coordinates, a grid. You want to draw a line across that. If you want to draw a perfect 45-degree line, well, it makes sense. It's easy. You just, every other, up one, right one, up one, right one from 0, 0. You just mark all of those in a diagonal. If you want to draw straight along or straight up, it's easy. It's obvious how you do that. You just mark all of them. If you want to draw a line that's like 30 degrees, how do you do that? How do you decide at what point, like, the line that you're drawing on the first row should move up to the next row? How do you mathematically determine which nodes of that grid, which cells of that grid should be, drawn in and which shouldn't? Bresenham's line algorithm is the answer. And it's as simple as y minus y0 over y1 minus y0 equals x minus x0, x1 minus... I don't know about... Listen. I know it in code. I don't know it in this. The idea is fundamentally that there's kind of like an error that builds up over time. That as you move across the line, if the line's supposed to be doing this, okay, when you're at 0, 0, that's fine. That's perfect. That's exactly where it's supposed to be. When you're at 0, 1, it's not quite where it's supposed to be, but it's still closer to where it's supposed to be than if you shifted it somewhere, shifted it up by 1. Get to the next one, yeah, it's getting far away, but it's still better in this position. As soon as you hit a certain breaking point, then the error, pushes over a certain threshold and you move up by a column. And it's as simple as that. And the way that this is expressed programmatically is just so brilliant, so simple. Like, all of this complex bullshit, this is what it comes down to right here. It's actually less than that, I feel like. Plot line low, what is this? Algorithm can be expanded to cover slopes between 0 and -1. So you're showing on... I really hate how things are documented in general. The people who understand complex things have no ability to communicate them. Just really disgusting. And like, this is the kind of shit that you usually see. Like, the first time that I see any code, they're already like talking about an alternate expression or something. Okay, I think this is the actual code. All of the derivation for the algorithm is done. One performance issue is the half factor and initial value of d. Since all this is about the sign of the accumulated difference, then everything can be multiplied by 2 with no consequence. Yeah, there's a little bit of weirdness at the end. Don't worry about it. I think this is it. And look at how simple this algorithm is. Let's run through it. So, dx. I think we're going to say that dx is the delta. Change of x. It's the derivation, maybe. It's the... How deviant is it, is another way that we could say. How much of error have we accumulated in x? It's equal to x1 minus x0. So we've got, you know, we're doing interp math, interpolation between one point and another point, and at this point it's linear interpolation. It's x1 minus x0, so it's really just, where's the, you know, you're looking at the two ends of a line there. dy, establishing y1 minus y0, so this is finding the width and the height, basically. Yeah. D equals 2 times dy minus dx. So we've got the height minus the width. We're multiplying it by 2. In order to square? In order to bring it into this grid space? I mean, if you understand the arithmetic, then you go right ahead. For x from x0 to x1, so for each step in the horizontal line, plot xy, if d, so d is going to indicate probably our error state, if d gets greater than 0, then y equals y plus 1. So this is the point at which we decide whether or not to move up in the row. We're starting at 0, 0, and we're going on that 30-degree thing, so we're going dit, dit, dit. When d gets to a point that it's greater than 0, then we jump up by 1, and then we subtract 2 times dx, and that's the math part of things, the actual algebra that, you know, why 2 times dx? Because it's the square of the root of the sum of the imaginary, you know, it's that. Anyway, really simple concept. Like, look at how few lines that is, and it accomplishes this. It accomplishes turning a line into, you know, this beautiful grid-based thing. It's like, this is the foundation of A star. If you know what A star is. I don't know if it is the foundation of A star or not. But let's just take that formula and let's bring it into our space. Okay. So there's too much indentation. Well, suck me off. I'm gonna... What do you mean, too much indentation? Were you, like, just falsely reading that?
Impressive.
I guess we needed a colon there. So, 2 times y0 for y, x0 plot xy. If d, you need a colon there. Yeah, you're fine there. And then d equals d, end if. We don't even need that. Look, we've managed to consolidate the code down to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines of code. And then plot xy is... So this is going through it each one at a time and dig. Yeah. Okay, so this is our formula, and we'll actually name this Bresenham, right? There shouldn't be any code here. You don't know. Shut up. We'll name this Bresenham. You don't know what I'm doing, right? Do you not know what I'm doing? You don't understand because I didn't define it. Find plot line. There we go. Now it's Python code. A couple of colons, def. 4x from x0. No. 4 from x. In range x0, x1 plus 1. Start end. Yeah, I think that'll be it. 4x in range of x0 to x1, and then how do you determine whether positive or negative there? Because you have to tell that to range, don't you? Because x0 could be higher, or it could be lower, and we have to move, you know, in the correct direction, depending on which side we started. And so we have to determine that here on the line. So we can do 1 if xo is greater than, is less than x1, because then we have to increase else -1. So that's a little thing that we haven't seen in Python code. We're getting into some intermediate concepts, I guess. Expected a comma. Why did you expect a comma? Can we do that in this code? Is a good, you know, in this game anyway. You just threw an error which would suggest that we're not allowed to do this kind of a thing. It's an inline statement in Python, so we're saying we want, in this space, we want a 1 if x0 is less than x1, else a -1. It's pretty straightforward, pretty obvious what it's doing, but this is the structure of like an inline if statement. You can do this in Python. Can you do this in the game? It just threw an error, so maybe not. We will see. But so now that we've got the concept of Bresenham in here, how does it implement into like our move code? Expected a comma or closing bracket. Yeah, it looks like it's not going to support that sort of a thing. It's fine. We can do it ahead of time and say direction equals, and I wonder if will you allow me to do it here? Because it is a valid like syntax. Direction equals 1 if x0, else -1. There shouldn't be any code here. Try removing it or putting it on a new line. Alright, so you won't allow me to do it in your game here. That's fine. We'll just restate it as a proper if statement. If x0, x1, then this, and then this. It is, you know, trying to teach. And not trying to be, you know, all everything that you can do in Python in a game. What? This is not... Oh, else. Sorry. equals -1. So that allows us to determine which direction we're supposed to be iterating in the range. And I think that's the way that we go. There must be a colon at the beginning of every code block. Thank you. You are helping because, like, I brought in some foreign, you know, some foreign code here that wasn't formatted for Python. And, between certain things not working in the game and the code needing to be augmented. So, let me grab this. The move to, because this is what I want to do. I want to use Bresenham, okay, for things like, watch this, we're about to see it, okay, so pay attention to the drone in the background here. He comes through here, he checks everything, and then he's got to come all the way back down to here. And see how I went woo, woo. He could be going da 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 da. He could be figuring out where he actually needs to, he could be cutting the shortest path across there. I don't think it will save any time whatsoever. I think there's probably a set speed for traversing in either direction, and by going da 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 and da 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 da, it's going to be the exact same as going da 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 da. You're going to go the same number of downs and the same number of lefts. But I want to do this because it's neat, it's fun, and it's also like a simple application of a classic, algorithm that has been used for decades for this kind of, line raster calculation. So we've got Bresenham here. How do we use Bresenham in this scenario? We've got the place that you are and the place that you want to get. In our loop, we want our loop to basically just be Bresenham, right? You can't trust the system, man. Definitely not. Lots of errors. Lots of you could copy it in from Wikipedia, and it's got like end if in it. Like, what were we talking about here? What language are you coding in 2025? Wikipedia. So, and they want me to support them with money. Come on. It's a contributor-based system. So what we do in our move to algorithm is first we got to figure out where we are and where we're going, right? So we've got destination X, destination Y. That's where we're going. Where we are is cur X, cur Y. The difference is not something that we need to calculate anymore. I think Bresenham is going to do that for us. Right? I guess what we need is like the directionality. Would be nice to know. Right? So if we were to change this to direction X and direction Y, and then what are you going to be equal to? You're going to be equal to, well, I'll probably have to split this into like a full crazy if statement because you don't really support that here, do you? So if cur X is greater than destination X, I'm seeing like the IDE part of this is working a lot better than it was before. Maybe it's like it doesn't work across files is my problem, like with imports and stuff like that. Maybe it doesn't work consistently across files and imports. If cur X is greater than destination X, in fact, I would rather say if it's less than destination X, then direction X is going to be equal to 1. In fact, maybe I'll just say IX, because it's like increment X. So if cur X is less than dest X, then we're going to increment positively as we go. Otherwise, oh, no. I did turn off the tab thing as, who sent it to me last time? During the last stream, you hit me with Rubber Ducky, was it? Sent it along? I did turn it off, so if I go into controls now, unindent, it should be Shift Tab. That's what it was originally. Now does it work? It does. Okay. It does. Control Alt doesn't work at all. So I don't know if that's a bug or if it just can't, take control. Or it's a bug in that I can set it to Control Alt and then Control Alt doesn't, Control Tab, and then Control Tab doesn't do anything. So it is a bug, no matter what, however you interpret it. So if curx is less than destx, ix equals 1, else ix equals -1. This statement, all of this, in Python can be consolidated to ix equals 1 if curx is less than destx, else -1. All of that can be consolidated into this, but not in this game. So just giving you a tip. Like all this crap. Also, if you were, if you had to write it in this format, usually write something that's as simple as this, like this. It doesn't follow the PEP convention. Sometimes I'll do it like this just to like reinforce the idea that it's an if-else statement, but like if I've got a one-line else, sometimes I'll even flip my if statement so that the block of code will be in the main section just so that the else can be a one-liner and be written like that. Python is not as stingy about like its white space requirements as the PEP conventions might make it seem to an outsider. Python will run in a number of different, scenarios that snooty, stuck-up Python people will tell you, well, that's not how you're supposed to do it, and they're just objectively wrong. Like, it's a bad, they are bad conventions in a lot of PEP instances. You're just wasting, like, line space. You ever go to read, like, Python code and it's just, it's for fucking ever. And it doesn't have to be that way. It's how you're choosing to write it. And you're choosing to write it according to a convention written by, neckbeard Linux jackasses in their fucking basements. That don't give a shit about communication. They're not thinking about how will this read to the next guy after me. So this, now we repeat again entirely. It's so nice to have shift going. And the idea will be we do it for X and we do it for Y. So we figure out the direction that we need to go. We've got the destination X and the destination Y. We've got the current X and the current Y. I don't think, if you're calling move to, you need to pass a value. We're not going to do that. There's not going to be any default value for this. Like, why are you calling this if you're not sending something? Not sending a value through. So move to dest X, dest Y. We get the current X from our current position. We determine which direction it's going to be, how we're incrementing, whether we're incrementing forward and up or, back and down. And then having that data, now we can hand it over to Bresenham. And I think we're getting rid of this kind of a thing. We want for X in range. I'm just going to push it down for now. But so for X in range, X0, X1. Well, we do have to do our calculations. I can't not have that. And in fact, like at this point, I'm going to hand it off to Bresenham. I think it's going to be best if it is all just like one Ham's line algorithm. If it's all in one algorithm instead of having like Bresenham and as a separate function, I just feel like we're going to end up calling that function like way too often. If we just do it right here, it's probably the best way. So X0, X1, Y1, Y0. I think I'll switch it to my language. So X0 is actually curx, and then Y0 is cur-Y, or current Y, and then X1 is our destination X, and Y1 is our destination Y, and then we've got you're equal to our current X, current Y rather, right, Y0. And then you've got 2 times dx minus dy. I think this is actually like what I would call the error. And so I might switch that over. I think, if I remember like why this works and how it works. What did you do? Error. I'm going to switch this over to, like, I want it to be legible, you know? It's a thing that the people who, the boffins who come up with this stuff, and then the people who come around to explain it, they don't know what legibility is. What?
Who? Legible? Legilimons?
So for x in range of current x, I don't understand how you intend me to use this, to destination x. Okay, if I don't type it all the way, then it's good. And then we need the direction, which is actually the ix. And then plot xy, if error is greater than 0, then y equals y plus 1. Are you sure of that? What if y equals y plus iy? Is it always plus 1? Like, you're always going up from one to the other? I don't think you are. I think you've got to do y plus iy, which is either 1 or negative 1, depending. And then we iterate on the error, so we correct the error. Yeah. I think that actually does it, unless I've missed something that needs to be converted. So that does the whole thing there, except for this plot xy. So what are we actually doing with the xy? We want to move to the xy. So this is the point at which we now need our movement code, which is like this. Right here, we need to move. So move. If diff y is greater than 0, we don't have a diff y anymore. We have, if iy is greater than 0, then move north. Yes, because then it'll be 1. So really what we could say is if it's equal to 1, then move north. Otherwise, it must be equal to negative 1, in which case we would move south. Except for we don't want to move on the y there. We want to move on the x. So this would go... Well, no, we want to move both, don't we? We want to move both of them right there. Yeah. So let's get our x code. So move was correct. We just want to do this one first. It doesn't really matter, does it? So if ix is equal to 1, then move east, else move west. And then if iy is equal to 1, move north, else move south. This is iterating. So we don't want to actually do that. We don't want it to happen every single time. We need to be determining... Like, this is telling us... X and Y right now are telling us where we want to get to. They're not telling us to move, necessarily. We move if we need to move. So, in fact, I could express this... I was right in my, a second ago... where if error is greater than 0, then we move up by the y. We're always moving on the x. It's down to whether or not we move on the y. And when we move on the y equals y plus iy? Yes. Is that necessary to actually track that? I don't think it's necessary to track x or y, actually. Is it? Like, do you do any math on that? Once we're in the for loop, you're just handling the error and moving in a direction each time. I don't think we have to track any of it. So in this case, we want to move up. Or south, depending on which direction it is we're supposed to be going. But yeah, we do the move y. And then the error gets updated. But the error is no longer in reference to the x or the y that we prepared. We've got the x in range here that's handling the... It's just iterating the correct number of times, actually. which means we probably don't need... Yeah. We don't need all of this. We just need to know how many times we need to do it, which is obviously it's the abs of destination X minus current X. And so that's an unsigned. Abs is absolute, so it's an unsigned value. We subtract where we're going from where we are. That gets us the width. It might be negative, but then we make it absolute, so now it's non-negative. Now we know how many times that we need to iterate, and then internally here we move on the X. Every time we do that, by the way, we always move on the X, and then Bresenham takes the wheel. I mean, yeah, takes the wheel, sure. just go ahead and write it. And then, if the error is greater than that, then move on the Y. I don't like how, at the end of a sentence, if you're suggesting a thing and I hit enter, like, if that thing's still up there, then that means that, like, it should select that and put that word in it, so it shouldn't go to the next line. It's not a carriage return at that point. It either needs to disappear, so that I know that now if I hit enter, it's going to be a carriage return, or if it's still there, then enter is not supposed to be a carriage return, it's supposed to be an answer to your pop-up. See how this, like, IDE really needs some work, the IDE aspects of the game. Yeah. And then we don't need any of this anymore because we've put it into the code. And so this is our new move to algorithm. And we give it the destination, we've got the cur X, the cur Y, and we should move in a Bresenham rastered line. So we get the current where we are. We've got the destination that was passed into us. We figure out which direction we should be traveling to travel along this line. And we pack that up as IX and IY, which we use later to determine whether to move north or south or east or west. And then Bresenham's algorithm comes down to, wait, dx minus curx. That's actually, so we've already got this figured out. In fact, can we just go ahead and change this and say that this is the, I mean, what it is it's the width of the movement. So I'm going to say it's the width of the movement. Width and height. You know, it's you're saying, but linearly, like, what do you mean width and height? You're talking about length of X and length of Y. Alright. But it's the width of the movement. I'm going to use width and height. So then that means that we just transfer all of these, we make them conform to our new language here. And now we can see a little bit more clearly, like, how this works. Squints at pawn cam. Are you sitting on the floor? I'm on my bed. Rubrad Duki. Rubber ducky. And I did the thing, you're the one who sent me the thing, right? Last time on how to make it so that shift tab would work. And look. Look. It works. I did it. Thank you for the improvement, the life improvement. This is my bed setup. My whole life is lived here. I have to stay horizontal most of the day. For the sake of my myalgic encephalomyelitis. So yeah, I think this works. This could work anyway. This is good enough code to put in place and see if it'll do a thing. But we're not going to interrupt a giant pumpkin harvest. So let's have the giant pumpkin harvest first. We just brought in Bresenham's Jack E. Bresenham from 1962. Their rastered line formula. I just brought it in and we're going to integrate it. So, and then it's going to replace this as soon as we pop this pumpkin. There we go. And I stopped it before we wasted a bunch of seeds. Okay, so new move 2 algorithm. Is it going to work? Does it work? Will it work? How could it possibly work when it's this complicated? Right out of the gate, you never expect this sort of thing to work. If it works, I'll be stunned. I'm going to need, you know, we're going to have to hunt down some bugs. Alright, so it should end up writing, fuck you. It's the Bresenham part is working. I just don't know how it's picking its lines. I don't know why it's moving the way it's moving. Okay, that's fun. Stop, because I want to, like, observe you a little bit more. You did the first row, and then you did all the way up here. And then you came back to the corner. Okay, let's look, because now that we've seen it, did this, and then it went up here. And came across, and then it came back, and so it went back to 0, 0. That's weird. When can you get more drones? I saw it in the tech tree. I wasn't driving toward it or anything. I'm really just here today to, like, optimize and... Mega farm. More drones. You get the ability to spawn extra drones, but I have to unlock it with a 2,000 in-game purchased out. No, I don't know what they are. They're chests. I haven't run into chests yet in the game. Maybe we start selling our crops on the open market. All right, let's try and get an idea of what's going on in our formula, our move formula now. So let's stop it when you get to stop it when you get to in the plant area thing. For Y in range. I want to change this too. Like we're gonna do some work today. This is the beginning of it, and Bresenham is already doing like diagonals, which I love. Just didn't expect them to happen yet. So we do that. I think I'm gonna stop us there. Yeah. So go and go. It should stop here, and now from here we can step through. How do we do stepping? By, like, at the keys? Stop, start, pause. Next step is F11, thank you. I don't really do this kind of, I usually just work with prints and stuff like that, but in this game we're doing it this way. Alright, so we want to see the line algorithm executing. Okay, something is happening. Oh. Well, we can't see it without turning the thing on. This is very inconvenient. I have to turn code highlights back on. So you just, you know, you suffer. There we go. So I've already missed a bunch of what I was here to look at. But if y is equal to 1, move north. It is. Error equals error minus 2 times width. Okay, let's start by just seeing what numbers are coming in here. So let's print dest x, dest y when it comes in. So stop and start again. 0, 0. Right. And go. 1, 0. 2, 0. 3, 0. 4, 0. 5, 0. And then 0, 1. 0, 1 moved us up here. When it should have just gone to there. So, when we look at how I put in the Y movement, if error is greater than 0, then we do the Y movement. Let's get Bresenham up here. See, like, the original formula. Because I modified it in how I thought would be, like, our, the best way. I would prefer it to be up here, game. No? You've got opinions? Okay, never mind then. So is that the whole formula I'm looking at? It is. Good. Alright, so Bresenham is, adjusting the X and Y. They're moving the Y down here. But we don't have to track the Y. If you look at this algorithm, it's unnecessary. Like, X just needs to iterate in the correct direction. And we're doing that. But we're not, like, recalculating. The error is being recalculated on the virtue of the, like, the linear interpolation is what I think this basically comes down to, on what I'm calling the error. But this is... It's based on the width and the height. Error equals error minus 2 times width, which, by the way, can be expressed like this. Error minus equals 2 times width. And then error plus equals 2 times height. And isn't this just getting more and more legible the further that we go? I called it width and height. It's the amount that, it is the width and the height of the area of movement. How are we getting wrong values in the middle? How is it that our error is greater than 0 every time, and we're moving on the Y every time? Right? Because that's what we're seeing here. Just look at Bresenham closely. This wasn't in there originally. That's me determining directionality for the sake of this. Which is a fair expression of it in Python land. In fact, if I'm gonna restate it for Python land, I'm gonna do like that. So every time, every iteration of X, error gets added 2 times height. But only when the error is greater than 0. This seems wrong to me. Only if the error is greater than 0. You know what I'd like to do? let's find my usage of Bresenham in my my old code. So we go to GUIable 2. This is the branch where I've been developing my code. And I want to look, hit the various commits. Since May 4th, 2019. You want to sort these in the other direction, buddy? How does this work? I don't want to compare changes, actually. I just want to see the history. Yeah, yesterday I did this is an incredible push that almost doubles the performance. In fact, yeah, pretty much doubles the performance of the thing. I found my last big performance gain. So I would have mentioned Bresenham and instant scrolling right here. So this was September 12th. I implemented Bresenham. And Bresenham will appear... I'm going to have to go to a different color. Probably in the utilities. Um, what am I seeing here? Point is in rect. Conform to animation. Aha. Yeah, it'll be down here. When I was doing animation this way. I don't like the way that this is being representative. Would you mind fucking off? If I search for Bresenham again. Here we go. Bresenham's distributed linear rasterization method. Error equals 0. For I in range of steps, the number of steps, then error plus equals to excess. If error, see how much cleaner I express this concept? Let's just pull this out so that we can read it in a place that doesn't look like shit thanks to GitHub. Like, God, GitHub, really? So give me that, and let's come on back over to the farmer. Give me a whole new thing, and drop you in. Yeah, my code's going to be a little bit more... So this is what I was talking about earlier with the idea of declaring types. There is no needed strict typing in Python, but you can do it. And so in my actual Python, you'll see here I've said that delta, the change of pixels, is supposed to be an integer. The delay that's supposed to be passed in is supposed to be an integer, and we will be returning a tuple of integers. And that's actually the wrong... I think that's wrong. Like, ... doesn't just mean integers repeated. I think ... means it can be anything from here. I don't know. I don't entirely understand the PEP convention. I just, do it until my IDE shuts up. But so I was using a series of steps here. But I've got the excess. I was passing the amount of change. I was getting the excess from the modulo of the amount of change in steps. I don't understand it entirely, what I'm looking at. It's just been, you know, too long. I don't use this system anymore. But I am... I'm trying to, like, compare the two of them. We got Bresenham over here with if error is greater than 0. We were always iterating positively in this code, too, so that simplified things for me. I'm also doing it in the other direction. Error plus equal to excess. You've got the error, you've got that happening under here. Is that the problem? Did Wikipedia give us a bad fucking formula? Because this is supposed to come before you, before you compare error. And that's what I was looking at this earlier, and I was like, this math doesn't make sense to me. Like, how would error ever not be greater than 0 if we're subtracting from, or we're adding to it every time? Like, but we're only subtracting to it some of the time, and it's after the operation. And so is that the problem, that we just needed to flip that up to there? Let's drop the print that I put in at the top of this, and then give us another run. No. It still went every single move. Let me put that print back in then. 2-0, 3-0, 4-0, 5-0, 6-0, 1-0. Wait. And then 0-2. Hang on. Had an idea here. Browser window is on top. Well, thank you for letting me know. Yeah, we can leave that open anyway. Okay. So I've brought in Bresenham. Well, I've brought in my formula that was in GitHub over there. And apparently you guys didn't see. Because of the goddamn window being on goddamn top. And no one goddamn tell me about it till little magnets showed up. The conceptual, like, the simplicity of Bresenham is so, you know, beautiful, and I just don't understand why, why we'd have so much trouble with it. So, Bresenham's line algorithm. Destination x minus the current x, we get sort of the length of the x and the length of the y. I keep thinking about it that way, as well as width and height. I think I'll go ahead and change that, since my brain keeps, like, arguing against me. Length x, length y. See, and I'm still in here, but I'm done. What do you expect me to do? You created this ID. What do you hit escape every time? So length y, length x, y equals cur y, In what way is y even used after this point? Because I just don't think it is. Y is not being used at that point. So our problem is that error is always greater than 0. Hey, wait a second. Where's the line that was supposed to be in here, damn it? That's what I was trying to give a try to right there, and it wasn't in there. Alright, maybe that's it. That was the fix I was just trying to try, and I don't know how it ended up not in there. What do you got a problem with? Oh, height doesn't exist anymore. Yeah, of course. I was changing the names, and then I got distracted by probably solving the problem. So, length Y, and then if we've got any more widths, they're length X. Height, width, height, width. It looks okay. Go ahead and run. Come on. No. So every single time, okay, the X movement is correct. That's easy. But every single time there, error was greater than 0. And so it kept moving up and moving up and moving up. Error should have been greater than 0 once. And here is same problem. Yeah, start this thing over. That is correct. XY, XY, XY. And then you went all the way up there without even talking to me. Actually. And then you printed 1, 1 when you got there. So 1, 0, probably it printed and then it ran up to here. And then 1, 3, 2, 3. And then 1, 4, 2, 4, 3, 4, 4, 4, 5, 4. One, 4, 2, 4, 3, 4, 4, 4, 5, 4. I think... Is it being called incorrectly? No, it said 1, 0 and it went to there. Yeah. So it's out of place. I think maybe this last movement is a problem, but 1, 0 and it went all the way up there the whole friggin' way. So... Let's... Forget about printing that. Let's print the error. At the end of it. Alright, can I just F5? No? You don't know which one it is. Those are some weird numbers to see. I want to get to the next diagonal movement here. I love the cloud thing here. Okay, we need to focus on just like the earliest problem, because it gets wackier after that. So the earliest problem is that when we go to 1, 0, we've got a massive error. Why do we have a massive error on 1, 0? Why are those numbers positive at 1, 0 when they weren't at 0, 0? We were at 0, 5, right? In fact, that might be useful to do, would be to print cur x, cur y, dest x, dest y, and error. I love this little, cloud writing thing here. It's a little bit too much data, though, I will say that. A little bit, slightly too much data to try and bring in. Can I use this format? Am I allowed to do this? No, doesn't look like it. So in Python, if you want to do an F string, you print an F string, you can put variables inside of your string, and then what I would do is something like this. I would make it very legible by doing like that. And so cur x, cur y, but I'm pretty sure that this is the fact that it didn't change colors there. If it's between quotes in this little game, then it's a string. A string is a string is a string is a string. And that's reasonable. Yeah. Alright. I guess let's stop being, clever about it. Stop having fun. And, maybe just throw in a little something like that to separate things. And something like that to separate things. And now, this is our output here. We should be able to run it. And get some results. I'm going to stop early. Because we wanted to see this. We went from 5, 0 to 0, 1. And our error was 19. And then it only got higher. I think this needs to just be subtracting. Like, what's 31 minus 19? 12. So if we were subtracting from that point, then we would end up going up by 1 when we got that negative 17, whatever that value is. I don't understand, because we just copied this over from Wikipedia, and the jackasses at Wikipedia, or, well, the people who contributed, have clearly fucked this formula up, or are expressing it in some, dead nomenclature that doesn't make any sense, but they're making it look like it's code, But yeah, I think somebody's gone and done and went and fucked this up. So error is plus equal to 2 times length of y. So the length of y was 19 when we did 5, 0 to 0, 1. The length of y should have been 0 minus 1. I'm sorry. Like, let's work through the actual math here. We were going from 5, 0 to 0, 1. Length of y is destination y, which was 1, minus current y, which would have been 0. So it should have been 1. And then error would have been 2 times 1 minus the length of x. Why is the length of x involved in this at all? the error equals 2 times length of y, so it should have been 2 because we had 1. And then when we got down here and we saw that it was positive, well, error should have been plus equal 2 times length of y, so it would have continued getting more positive still. Which just ain't right. I'm going to switch you to subtraction. And then maybe internally you can do some addition. I don't completely understand. I see that there's a problem, obviously, and I see that things are backwards of where they really should be, and I flipped some things around, but I don't feel like I, solved for something here. Everything's working again, though. Are we getting the benefit of Bresenham, though? We should see it now. Yeah, look, it does the diagonal movement to get where it's going. That's all that we were trying to do there, really. And look at our data coming in over there. Okay. I managed to fix what Wikipedia done fucked up. Oh, wait. I had it fixed. So how did we manage to just get fucked up on the wheat? Oh, that's gonna be crazy. Let's keep watching. See what comes up next, because if it's like a cumulative thing, then it'll get even wilder as we go. It just went straight across, and then went straight across, and then, So when it was up here, it's 511. And then it should have been called to 0 to 60. So, okay. That's we focus in on that now. Is it being called to what it's supposed to be called to? So when we get near to the point of error, I'll pause it. Which is here. Okay. Now we've got like prints and stuff that are actually in here that can help us. So where are we? Right. Looking for, we'll re-enter the move to. Here we go. We're in the move to. Move east. And then we printed that it was 5-1. What? Cur X, Cur Y. 5-1 and 0-2. Why would you think 1? You think you're at 1 for some reason? Huh? Oh, it's down here. It's not it's the bottom is what I need to be looking at. And again, the IDE is supposed to fucking snap to the bottom. 511, which is where you were, and then it's supposed to be 6-0. 6-0. So why did you decide that from between 11 and 0 didn't require any movement? You remember the other thing that I was saying is why the hell is length X involved in the error? Like, why are we... We're always going to be moving left to right. That's just a fact of life. If you're always going to be moving left to right, then how would you do this? How would you go up like that? Huh? Like, you would never be able to get past a 45-degree angle if you always move right, but you only sometimes move up. Is that like a... How does Bresenham handle that? Because Bresenham is always moving to the X according to this horrible fucking... Why am I looking at this? Why are we trusting this piece of shit that we have we have proven is wrong? Bresenham, line, algorithm, Python. That's, yeah. Simple implementation of Bresenham's line drawing. In fact, they got it at Geeks for Geeks. They're okay. Except for this shit. A naive way of drawing a line. Are you kidding me? Here we go. Bresenham. Fucking get to the fucking point. God damn it. X1, X2, Y1, Y2. So we're talking left, top, right, whatever. It's not necessarily that. Yeah, slope error equals new, and so this is probably a viable thing. Load the implementation of the above algorithm. What? Line is drawn from left to right. That's an assumption. That's not correct. X1 is less than X2 and Y1 is less than Y2. That's not correct. It's not necessarily correct. So they've given us a shit version of shit. It's fine. We can adapt from here, all right? So minimize, and that actually goes off screen this time. Thank you. Fuck that. What they had for Bresenham there. So X1, X2, Y1, Y2. We're actually taking in more like X1, Y1, X2, Y2. But it doesn't matter. We get the M new, whatever that means. Let's see if they explain themselves. M equals Y2 minus Y1 divided by X2 minus X1. So it's again the length of the Y and the length of the X, but they're divided against one another. Okay. But you've reduced. Like, you say that, and then I look at the code, and that's not what's going on in there. Consider the value below value M. Multiply both sides by X2. I see, you're taking out, you're showing how it's, like, it reduces in complexity. So 2 times just the length of Y and Y1. Error. I like slope error. That's good. That better expresses it. Slope error. I don't know why we're saying new, but again, Geeks for Geeks is, they're fine for X in range X1, 0, -1. You're determined. You're going in a very specific direction there. Y plus equals 1. So there's a bunch of assumptions. It said this version of the algorithm makes assumptions about we're always moving from left to right, we're always something, and so on. So this will probably have to be expanded out again. You know what? Fuck Geeks for Geeks. They've given us I'm falling into the trap of like relying on an algorithm. We know that it's a bad implementation of an algorithm. Fuck you, Geeks for Geeks. Bresenham. It's the whole point of it is that it's simple. Just give me a version of it in Python. I've written it before for my own application. I don't want to have to fucking think it through live on stream. I didn't think I'd have to. Welcome to the internet 2025. Ask a fucking AI. You know, oh god, no. 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 Python. You got it for Python? What do you got for Python? Holy fucking ballsing shitting balls. This ain't it, bro. This ain't it. This is like way more complicated than necessary. Determine how steep the line is. Rotate line. Because Bresenham. So this actually is handling the things that I was saying. Like, if we always assume that we're always traveling on the X, then it's not going to be able to do a steep line. This is actually handling for it. So it swaps the X1 and the X and the Y values in order to just keep a simple thing. Swap start and end points if necessary, and store swap state? What? You already did. If is steep, rotate the line. If x1 is greater than x2... Okay, so this is also flipping us so that we can go from left to right and right to left. Recalculate the differentials, which is just going to be a whether it's negative or positive. This is stupid. Like, you're doing it right, but you're doing it all longhand, and you could use abs. You could conform the range by determining whether or not it should increment positively or negatively firsthand. Oh my god. All right, let's this is also not great. Well, let's bring it in and fix it. I'm actually reinventing Bresenham today for the internet because in 2025, no one has a simple expression of Bresenham that is correct. Ask a fucking AI, I guess, is the answer that everybody goes with these days, huh? Yep. So we're not going to do it this way. I'm gonna get rid of your little fucking sampler shit. Bresenham. And again, we're gonna do it in a way that makes some fucking sense and say, tell me where you're going. I mean, I'm gonna write it for our application here, actually. So, destination X, destination Y. And those are both integers, but we don't express that in the game here. Set up initial conditions. X1, Y1 equals start. No. X1, Y1 equals get pos X, get pos Y. I also wouldn't mind if the game would automatically assume that I want to execute a function, put the fucking parameters in there, the parentheses in there. Like, it's more likely that you're just calling a function. Like, IDEs have shit. Alright, I'm in a bad mood now. I'm taking it out on anybody and everybody. But I have been complaining about this IDE since, you know, day one. You don't have to reinvent the wheel. You don't have to figure this shit out. How does PyCharm work? Just do the basics. x2, y2 equals end. That's the dest x and dest y. It's probably going to be easier for me if I just pack them into your values, right? I don't want to have to completely fight you. And so we get the dx and the dy, which I would like expressed differently, but I want to change I don't want to change all your values. Determine how steep the line is. Is steep is equal to the abs dy of the if it is steep. So are we ever going to use is steep again? Because I'm pretty sure we don't. So there you go. Rotate line if line is steep is travels vertically more than horizontally. I mean, that's what's really going on here. The issue is if the line is doing this, then we're fine because every time we're going to be moving right by 1. But if the line is like this, then, you know, moving right by 1, we're never going to be able to draw that line. So what we do is we rotate that line into this so that we're doing it right, and then we take the values out, you know, in the right way. That's the idea here. Swap the start and end points if necessary. I think this is dumb as balls on the surface. I think these balls are dumb. I don't see why you wouldn't just change the direction of your range. You know, why don't you just do it that way? You don't have to recalculate the differentials. It's just a difference of negative or positive, which is a fucking waste. So yeah, I don't think so. I think if x1 is greater than x2, then we could use swapped equals no. Where does swapped come back up? If swapped, reverse the list at the end. Yeah, that's just, it's dumb as balls. Whoever wrote this is also like, you know, they've got the third digit of IQ, but just barely. It just doesn't need to be like this. Why are we traveling, you know, in that direction? We can always just change the direction. So if x1 is greater than 2, we're always going to be operating on the x. So the idea would be if x1 is greater than x2, then the increment of x, got to do it down here in this one, then the increment of x equals if ix is greater than x2. It would be -1. So let's make it less than, and we'll say 1, and then else. Now you see, if you didn't understand like how I had coded the one before, I didn't really slow down to explain it, why I was doing what I was doing. It was to swap the direction of travel. Recalculate the differentials. Don't need to, because we didn't swap the values. We're just going to traverse them in the opposite order. Calculate the error. All right now. Y step. Well, see, now they use this code that doesn't work in this program here. Y step equals oh. So you're kind of already doing it, huh? This doesn't describe this correctly. Select direction of iteration for range x, y, ix. Range start, stop, ix. That's the idea there. We calculate the error. Where are you using the y step? Y plus equals to y step, whether it's going positive or negative, which you're determining based on, you know, the same thing that we've just done here. So let's just flip it. and say if y1, then iy, iy, select of, you know what? Let's just say this. Let's say select directions of increment. Yeah, that's fine. And then if that would fuck off. And so we get the x, we get the y. And then we get the error. Iterate over bounding box, generating points between start and end. We didn't use a bounding box, by the way. Y is equal to y1. Points equals, we're going to make a list of all of the points. So that's how this one happens to work. That's not how we need it. That's not what we're going to do. We're not going to append coordinates to a list. We're going to do x in range of x1, x2 plus 1. No, we're going to control the range. And so, x1 to x2, do we have to plus 1 it? If we want to land on it. But do we have? I don't think we have to. I think that's also like, if we want to go to 6, then maybe we do need to plus 1 that. But we then do ix here. So instead of all that shit that they did, we select ix, and then ix is going to determine whether or not we're going forward or backwards based on whether x1 is greater than x2 or not. So, yeah, I think if x2 plus 1, I think that's a problem. I think that creates a situation in which you can actually trip this up. I'm going to take that out and just try and remember that there was a plus 1 in there. Somebody write in chat. There used to be a plus 1, x2 plus 1. Oh, x2 plus 1 used to be here. I can't think of what I'd write here anyway. So, chord equals to yx if steep, else x. Oh, you're using the if is steep. Otherwise, it's xy. So we're either going to do yx or we're going to do xy. Alright, so we do need to know if it's steep then. That is necessary. So, is steep equals if is steep. And so we've held that value. Or why? And then this is packing them up, and we can't do that this way anyway. If I were to just, I'll start by just restating it. If is steep, then chord equals yx, else chord equals xy. We're not packing coordinates this way, though. So we're not like writing them to a list, which is what they're doing here. We're not doing that. What? Wait, what was your error? You had a problem and now you won't say it again, alright? Keep it to yourself then. For x in range, x1, x2, ix. If is steep, chord, and then error minus equals the absolute of dy. If error is less than 0, y plus equals y step. Error plus equals dx. I'm a little bit confused because I thought the whole point here was to, you know, we flip the line values so that x is always traveling right. We're always doing this based on the x, even when we want to do it like that. So we've rotated the line ostensibly, and then the idea is to ultimately have it act like that instead. What I'm having trouble with right now, Parson, in my brain, is how to express this as movement for us, because they care about the actual Y and the X. We care about how do we move right now. So if we were supposed to move, let's forget about the steep shit for now. We're supposed to move on one where it is there's more X than there is Y. There's always an X movement. Then this turns into, if it's steep, then we want to move. We have to determine which direction. And in fact, we can determine that. We've already determined that, haven't we? Yeah. So if x1 is less than x2, then we want to be moving east. So move equals, well, let's say, like, is move a command? It's already a command, isn't it? So we don't want to use move. M equals move east. Right? Move is a command. Move well, let me just mouse over it and make sure that that is the command, right? Am I crazy? Yeah, move east. All right, somebody's crazy. I don't think it's me. So actually, M equals east. Move direction equals east. Else, move direction equals west. This is how we do it. This is how we do it. Yeah, 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 yeah. So we pack this consideration into a one-time thing. Move direction equals south. Good. East, west, north, south. And then down here, if is steep. Shit. We can do this then. We could do east-west, west-east, north-south, because I need the opposite. I need to know what the opposite is. So we pack these up like this, and then depending on whether or not it's steep, I'm just wondering whether or not I can, like, make this access require, like, less if fucking statements. Every time we gotta say if is steep, if is steep, if is steep. We do it up here. We do it up here. So again, I'm just trying to make it so that we're not, like, wasting operation cycles. Why do this 900 times when you can do it once? You can make these decisions once. We've got the quality of whether or not it is steep or not. So what we do is, if is steep, then move dir equals west, else move dir equals east. And it's a lot of bullshit up here, sure, but it gets done once and then it's not happening in the loop. And then we've got the actual, you know, real goddamn values. So, and then we just flop them. And we don't have to be doing if tests in the loop. Do them once, you know? For you, so it would be south if it's steep because it inverts what we're supposed to be doing. Is steep switches north for... It switches directionalities. Damn it. I'm using it the wrong way. Is steep switches whether or not we're east or north. So that's east going that way. But if it were like this, it's steep. And so we want to be doing the... I think it's like this, then. Don't quote me, boy, because I ain't said shit, but I think it's like this. If it's steep, then you're supposed to be... This would usually be north, so it'll be north down here, which means you'd be east. I could be wrong about this. This might not be like just a And then it's just inverted, right? So you're west and you're south. Boy, I hate this IDE. And travel. And you calculate the error, and then internally, we don't have to ask about whether it's steep or not. On each iteration, on every single goddamned iteration, we will be moving in the move direction. We need the other move direction also, so we need to choose that also up here. But so move direction, error. If error is less than 0, then we would move again. Maybe I should pack them. So that it's move direction 1. And then move direction 0. Directions of increment and travel. But you don't know, like... So the default here, when it's x1, x2, we don't know what direction y travels in yet. So what I could do is this. Move dir equals none, none. Okay. So we establish the space first, and then what we're deciding is, you know, how to pack the first value in any of these paths. And even though it's a lot of code, number one, this can be expressed a lot, you know, with a lot less code in true Python. But even though it's a lot of code, how many if checks is it? It's if, so this is one branch, 1, and then 2. So you do 1, and you will either end up here or you will end up here, and that was your one thing. And then you'll do one more if branch, and you'll either end up here or here. So 2, 2, 4 branches, it's, you know, it's optimal. It's good shit, is what I'm saying. So now, for you, I'm not 100% on this part. It makes sense to one part of my brain. There's another part of my brain that's like, no, something wrong. It ain't gonna work like that. But yeah, this looks good. And again, we've got like Y considerations that just don't need to be there. We're not calculating using Y. We don't determine what the error is using Y. And since we don't actually care about the coordinates themselves, we just care about whether or not we're supposed to move. We don't need to be storing X and Y. We're just using it as a way of iterating. So we could even change, you know, this to just I, because it's not, it doesn't represent an X or a Y value. We don't know whether it represents an XY value. In fact, here, say XY, because we don't know. It depends on whether or not it was steep and whether or not we rotated it back up here. This is code that you know, makes some sense to me, at the very least. And it really is the very least. But, yeah, this is my attempt at writing what needs to actually happen. After we went to Wikipedia and they lied to us, and we went to Geeks for Geeks and they were like, this works, but only under the circumstances of the blue moon and the tide has come up the shore and that kind of shit. So I'm going to replace the move to... It's gotten a lot more complicated, hasn't it? Wow. Let's see. This is, it would really be nice to test this on not our entire system, but yeah, we've immediately got an error. Good. You can't assign a tuple element because tuples are immutable. Thank you. Yes. Good thing. So I can explain tuples now. The difference between a tuple and a list. So a tuple is declared like this, with the parenthesis sides around it and then the values that are going to go into it. Tuples are a very fast access method for packing multiple things into them. They are ordered. They are ordered. I was thinking of sets for a minute. They are ordered, so the way that you put them in is the way that you'll always find them. But they are non-writable. You cannot write to them again. If you want to, like, change what's in a tuple, you just have to rewrite the tuple entirely, which is why it's a bit faster than a list. And a list is like this. So it's as easy as that to change from a tuple to a list. We're now using the square brackets, and a list is a little bit slower in theoretical on the CPU sense that usually doesn't matter at all. Certainly won't matter in this code. But in exchange of that, you can read and write to the list, and the list you can treat it. It's like an array. So you can append to it, you can, you know, continue extending it to be as large as it needs to be over time. Okay, give this a try. Good, another error. I expect a lot of it. Unlock lists must be unlocked before this can be used. Alright. Lists cost 500 carats. Alright. Lists, I was just explaining, are a way to store multiple values in a single variable. You can create new lists like this, like I just showed. You can make an empty list like that. You can, you know, pack stuff up into it, and then access it like this, list brackets 1. So this would be accessing the caret value right there. 0, 1, 2. We always count from 0. 0's place, 1 place, 2 place. If you're accessing list 1, you'd get entities.caret back in that scenario. You can append to them. So if we append the value 7 to this list, 2612, we get 26127. You can remove the actual element by, naming what is stored there and saying remove the thing that's there. And so when we say remove 2, we're not saying 0, 1, 2. We're not removing the value 4. We're saying remove the value itself, 2, the element 2. And so it goes through and it sees, do I have a 2 in me? Oh, I do. Okay, I'll pull that out. Insert allows you to put something in, with append, we're just tacking it onto the end. 26127 just goes into the end. Insert allows you to stick it in exactly where you want it. So usually with insert, you're putting it at the very beginning, so you'll be inserting at 0. That tends to be helpful in data management, is either to append things to the end or put them in at the front. Putting them in at the front takes a longer time on the CPU. Again, probably won't matter in any code that you'll ever write, but it's important to understand that the best way to access a list is to append to the end, so that you're always putting a new thing. You're leaving everything that's in memory exactly the way that it is, and you're appending a new thing to the end like that. In fact, I should be doing this with my hands, because left to right, I should be doing it opposite for the camera. So memory stays here, we pop something to the end, or we put something to the end, and then if we want to change, we want to remove things, it's also best to be popping, is what it's called, from a list, from a lot of things, but taking from the very end, because again, you're just leaving everything that's over here exactly as it is. If you're inserting, then everything that's here has to kind of go, and then you put in the new thing. And it depends what data structure you're talking about, whether or not the code actually moves everything in memory. Usually there are smarter ways to do it, where it's like, okay, well, we're gonna switch which end is considered the beginning. There's ways to avoid having to do that depending on what the circumstance is. But it can, in some situations for coding where this really matters, it can actually be faster in Python to take a list that you've got, where you want to remove the value at the beginning or put a value at the beginning and actually reverse it. There's a method to reversing things and stuff like that. There are techniques that optimize how fast you can make this happen with very large lists, by actually reversing the list first and then popping it off, because popping is so much faster than iterating over everything and moving it, insert, insert. So yeah, that's some things, some considerations with lists. And here's pop, which drops from the end, like I said. And then we also get the length function with lists. So that allows you to determine, it allows you to know how long a list is. So we've got 3 values in here. And I said in code, we always count from 0, 0, 1, 2. That doesn't change the fact that there are 3 items in this list. It will return 3. We wouldn't say that there are 2 items in this list just because we started counting at 0. The correct language is to say that, there's 3 things in there, so length will be 3. But that is actually why the range function operates the way it does, so that if you say, for I in range of length of list, and there are 3 items in it, it will be for I in range of 3, and it's going to go 0, 1, 2, and then it's going to go 3. Okay, I don't go to 3. That's how we sort of get around the disparity between counting from 0 and, handling lists and lengths and stuff like that in code. So now I have lists. Well, we've got new behavior. I love that it zigzags everywhere. That's fun. Okay, we moved on to trees. Go ahead and watch that again. So it does the row correctly. the first row, well, things are 0. And then when there's an error, shit gets crazy. Okay. First off, let's print steep, which it isn't, and it shouldn't be triggering this. None of the calls should be steep here, so we won't see any steep. I just want it to be in there. Oh! That's why I wanted it to be in there, because none of these calls should be steep. Right? You do that row. Okay. Weird shit going on there. So, steep. You get to here, and then you go up there, and it wasn't steep when you walked this way. But then it's going to be steep when you head off that way. So let's focus on everything that's happening up to here. So this should be calling you to 0, 1. 0, 1 is coming into this algorithm. And what is happening? I'm going to stop here. Okay. And now our destination X is 0 and 1. Yes. And so we are at 5, 0. 0, 1. That's where we're going. And so you're -5 and you're 1. Right. That is what we need to travel. We need to go up 1 and we need to go left by 5. Are we steep? Doesn't say. Let's go forward. We are not steep, so we skip that. Yeah, we instantiate the move direction. If x is less than x2, x1 is less than x2, x1 is 5, x2 is 0. So it should be down here. Yes. So we set the range direction negative. And then we're going to check if is steep, and we're going to, so we should fall through, and we should end up saying that the direction that we need to be moving is west. Direction 0 is west. Yes, that's what we did. And now for y, y1 is 0, y2 is 1, so we want to be moving north. So we should fall through to here. Yeah, so direction 2 is north. That's right, west and east are correct. Now the error is -5 floored 2, so that should be 2. -3. What? -5 divided by 2 is 2.5. But it's supposed to be floored. Does this actually round it? Like 2.5? Error should be -2, not -3. I guess I don't understand the use of this. Because it's supposed to floor it. It's not supposed to round it. x2 plus 1 used to be here. Right. So we are now going from 5 to 0 in a negative direction, right? Good, that's fine, that should work. We move, and the direction that we're going to be moving is west-north, and we're going to be moving west here. Uh-huh. That is correct. So you've moved west. Floors toward negative infinity. Ah, okay. It goes to -3 instead of back towards 0. That makes sense. T-Carcass, hey, how you doing? So error minus equals the absolute of dy, which is just 1. The error thing is where Bresenham, or whatever the fuck his name is, comes in. So it's minus equal to, what is error currently? Error is -3, and the error was determined by this little thing. So it's -3, and we're going to subtract 1 from it, which will make it -4. It's -1, -3 minus 1 equals -4. And then if error is less than 0, then we move direction 1. So we shouldn't move direction. Yes, we should. On the first pass, we should. Right? Because we're 1 off. So we should move up by 1. Yeah. So we move up by 1. Perfect. Exactly what we want to see. Now error is plus equal to dx. Error is -9 now. What? Didn't we say that error was... It was -3, and then it was supposed to be minus dy, which was 1. And so it shouldn't be -9. I'm not sure how we got to -1. Maybe that's because it's already done the thing, and it was -5. And so we did -4 plus... Yeah, we did -4 plus -5, so we ended up with -9. So this is... It's all going in the same direction is the problem here. Unlicensed streamer did phone verification because my streams are just that good. So you've given up your privacy. All right, welcome to the CIA's, bingo book. For 2 weeks, I've avoided phone verification on Twitch, which now is a requirement to chat, but this riveting stream meant I had to chat to praise how well you are teaching coding. Am I? I'm just confused at this point. But thank you, unlicensed streamer, and welcome to jumping through the hoops that they make you do around here, huh? So I understand how we got to -9. This is the problem, though. We should have ended up with a value that is no longer less than 0. We needed to get a value that was 0 or above after this, because we've just corrected the error. So we're adding when maybe we just need to still be subtracting. Like, this isn't right. Or what we do is error plus equal to maybe the absolute, like we did up here. We did the absolute of dy. If we added 5 to the -4 that we had, then that would have fixed it. I think we got another code that was wrong. I think nobody can do Bresenham right, and I think this makes more sense, is that it subtracts in one direction and adds in the other. That's my best, theory right now. Let's start over. Wait. Alright, close. Very close. It's a lot closer than what we had before. I'm gonna let it run. I mean, it did find its correct place, more or less. We're slightly off. This isn't the TK enter I'm used to, says Kenneth. No one's used to TK Enter, don't lie. Hello, Kenneth. Welcome in. A streamer once told me, only edit a new instance of code so the old one can still run while bug fixing. Hey! Ah? Yeah. This doesn't run well enough for me to leave it running necessarily. It's fine. Is it doing the same thing every time? Or are we, like, moving off of... No, it's... We're maintaining the same spots. We've just got a little bit of an error now. But I fixed it by putting in an absolute that wasn't there in the code that we got from the fucking internet. I swear to God. This is where we're headed as a society, thanks to artificial intelligence. Thanks to the large language models. The people who wrote this shit don't actually know what they're doing. And so they got real close, and it worked in the one scenario that they cooked up and tested it against. It ain't right, man. It ain't right. Here's another idea. If error was, let me just, no, I'll leave it running. If error was -3 to start, and then we didn't do the absolute. The absolute was 1? Was it -1? So then, -3 minus -1, that's taking error away. We want to be adding error every time, I think. I think this is right. I would love to get the absolutes out of there if they don't have to be there, is what my brain is thinking, but they probably do. It's not like absolutes cancel each other out, especially when they're on different variables, dx and dy. But I'm thinking maybe. That's why I'm thinking that maybe. A streamer once told... Wait. It isn't touching that top tile of wheat. It isn't. The internet vote likely can't account for the Pac-Man physics of teleporting at the edge either. That's true. Little weirdities that are happening right now, which we do want to account for eventually in our movement code so that we aren't wasting, you know, travel time. We can just loop around and get there. But I wanted to do Bresenham's formula, and apparently I'm the only man on the goddamn internet who can make it work, because Wikipedia was wrong. This fucking algorithm that we got from... Where do we get it from? Is it still open? We got from roguebasin.com. Maybe it's right within, like, the context of all of the stupid shit that it's doing that's excessive and unnecessary and that I took out. But yeah, okay. Let's do the trick. Let's trip on some mushrooms over here. Pull the code out so that we can review it and try and figure out what the hell, man. So first let's just identify what is actually happening. And what is happening is we went across correctly the first time, and then we moved up, and we got to here, and I think we went up an extra 1, which is not what we want to happen. Obviously. The internet code likely can't account for the Pac-Man physics of teleporting at the edge either. Right. But it should be able to move across this grid. We're not asking it to interact with the Pac-Man stuff yet. So is my absolute that I wrap this in, is that even like the correct solution? I'll tell you what, we have to be working with this, we have to be taking this offline while we work on it. Okay, I'm gonna pause because I need to see more of what's wrong. We'll get back to the steep nonsense. When we get an error state, I want to print like the, what do I want to print? what helps me. The error and the dx and the dy. And I'll stop right after we print it, too. Go. Okay, -4, -5, 1. And we've got that information here as well. So what are we printing? We're printing the error, the dx, and the dy. So we're moving up. Because the error was less than 0. What? If error is less than 0 and error was -4. So now we're going to add to -4, we're going to add just 5 because we're going to abs it. And so that's going to bring it above. And so this should be right, basically. But then it got over here somewhere. I think it's supposed to be there. Like, where are you supposed to be right now? I think because you printed that. Got over there, and we got -1, -5. So we ended up with an error state that we shouldn't have ended up with. What if I mean, number one, let me do that thing that I was like, my brain was like, what if you just got rid of the abs? Like, this probably won't work, but, you know, sometimes your brain just knows something that you don't. Yeah, that don't work. What if I swapped you to subtraction instead of addition? Some weird ass shit. So let's go back to abs on both of those. See, the problem is that this is the actual, like, algorithm at this point. We're into the error state, and I don't, you know, off the top of my head completely, I don't have that held in my head, like, why this works. Which makes it hard for me to solve it when, you know, we find out that we've been given one that's shit. The other version of Bresenham that we've seen is the one that I was using before. If I go back here, and the one that I was using actually works from a 0 state for the error. We go back to the GUIable stuff in the history. And Bresenham and instant scrolling. This was in my own project. I was using Bresenham, which is why I wanted to bring it to this. I just didn't think it would take the first 2 hours, 2.5 hours, and we haven't had a live stream fucking break of the stream in order to implement a you know, system that's as complicated as it gets, as it needs to be right there. So, coming over here, this is the code that we've got over there now. We don't have to preserve it or anything. I'm putting you in here. This is Bresenham. This is the simplest version of Bresenham. And I'm pretty sure that it, like, presumes that you're traveling in a positive direction and stuff. But we start out with an error of 0. And then the error is plus equal to an excess. What defines the excess? Let's find out by looking in the rest of my code. It was the change of pixels that I was requesting, modded by the number of steps This was for an animation sequence. I think you are smart enough to implement the algorithm yourself without copying wiki code. I think that's where we are. Is I have to make sense of this myself. The base was the delta, the change of pix, floored against the number of steps, and the change in pixels could have been negative or positive. I could have been requesting. So that gives me a negative or a positive thing, and then, yeah. But it's the mod, it's what remains of the change in pixels after the number of steps. And I actually worked all this out, too. Like, I had already solved this problem using a method that worked off of the mod of all that kind of stuff, and then I was describing what I'd done to ChatGPT, and ChatGPT said, I think you basically just reinvented Bresenham's line formula. And then she showed me the, you know, this version of it, and I was like, oh yeah, that's a better way of expressing it, isn't it? So now I'm having to reinvent something that someone invented in 1962 that I reinvented the wheel because I didn't know it existed, and now I try and go get, you know, just expect it to be out there, and no, it ain't just out there. But so it's an excess. We start at 0 with the error, and we add the excess on, and we take the excess away each time that we fix it. Like, that's the simplest sort of concept at work here. So, if we started the error at nothing, okay? No error. And then for each iteration, we increase the error by a certain amount of excess. So let's say that excess is right here. Let's call that, let's say excess is equal to that. I don't know why. Each time we add some excess to it, okay? If the excess becomes greater than 0, was this run? Did I take that away? What did I do there? I killed something there. Then we remove the excess. Okay, what have we got here? Tried to read the variable error before a value was assigned to it. Yeah, sorry. Error equals 0. You're such an amazing person. Thank you for streaming, even though it takes a toll on you. Well, thank you for being here and watching and for saying such nice things. Like I'm really making an effort, when we all know that he isn't. He's barely even. He's phoning it all in. Alright, that's some crazy stuff is going on there. Excess is equal to, error equals 0. Error is plus equal to the dy, the abs of dy is how we used to have this. We had it, the absolute of dy, and then we had the absolute of dx. So now I've only changed things so that the error is starting at 0. Why? I don't know. But it fucking works. We don't know yet, but it's looking good. It's looking better than it was before. Just to not start the error off on some weird arbitrary value. Okay, so the steep, it doesn't know what to do with the steep. It was supposed to travel from 0, 11 to 6, 0, which means that's a steep line, and it had trouble with that, and it ended up here because it went. Okay, so we've just got one problem left, and it's the handling of the steep. I am literally reinventing Bresenham before you. And here's the steep again, and then it lands there. Got it. This is actually working okay enough for me to probably be able to justify breaking it out. So, with the steep handling, the idea behind that is that our calculations are assuming that the amount of, the steepness of the line will always be, in fact, I should do it this way for camera, will always be up to 45 degrees. And then when we go higher, what we need to do is, if we're going to always do the movement on a certain angle, then we can't always be moving on the row. We've got to flip it so that now we're moving on the north and the south instead. So when we do the steep, the idea was, when it's steep, if we were supposed to be moving east, then we move north instead. Because we've gone like that to like that. Once we've gotten to here, we need things to happen on the Y continuously, which would be moving north. If we're going up. So in the situation that we're heading up here, I want to just show you like the path that we're following in the code. And when we get to the top here and we're supposed to travel from there to there, then, in fact, maybe I can pause it when we get to that spot. Does this pause? It does. All right, keep going. You still got to do that row, right? You got a problem? Did I break something? I broke it. I stopped everything. Damn it. So what we're seeing is he gets up to here, and he's supposed to travel from there, actually, to here. So, in that moment, we've got 511 traveling to 60. So we get to here, and we're supposed to be saying that is steep is the diameter of the line, the length of the x, the length of the y is greater than the length of the x. So we're only moving a little bit on the x, we're moving a lot on the y. So it is steep, which means we switch what x1 and y1, we switch what's considered there. I think maybe we just don't do that, because I'm handling it here in the directions now. We don't need to flip the considerations of which one is which one if we're handling it in the directions. So maybe that's the only problem. Give me this, put it in there, run the damn thing, run the show. When it's steep, we used to be flipping the x1 for the x for the y. We would trade which was considered which. But I also solved it in the directions by switching which, orientation we were on. So it's basically like I flipped it twice instead of just flipping it once, and we ended up back in the situation that we were in. That was really close to what needs to happen there, except I expected it to have to travel all the way down, not keep going north. Let's see what happens when it, well, this won't be considered steep, so this will just run normal. I love that it does that. That's the part, that's what Bresenham is doing for us. It's managing to, it's rastering that line so that it travels on the diagonal instead of one at a time. Okay. Right, here's where we're slowing it down. And push you down here. Let's get into the real code. And up here at the top, every time that you start here again, I want to see. Okay, you popped it. And then you planted a new one. Okay. And now you're ready to consider where you're going next. So, where are we going next? We're going to 511. Wait, no. We're at 511. We're going to 60. AKA here. Now let's watch what decisions get made in order to get us to 60. So, we want to get down here to is steep. Is it going to be... It's true. It is steep. Good. So, how are we going to make these decisions? Is x1 less than x2? It is, which means that we need to move to the east once. Okay, I think I may have just conceived of what really needs to happen here, but let's just carry on. So we set move direction 0 equal to north. That's wrong. What we should have found out is that we need to be moving to the east. What should happen here is that move direction 1 should be equal to east. Huh? So it's really just whether or not we put it in the 0 or the 1. Yeah, which, by the way, can be expressed as this. Check this shit out. Move direction is steep equals east. And then we don't have to do any if testing at all, because 0 and 1, true and false, are expressed as 0 and 1 in Python. The largest calculation I've ever seen a person do was being off by 2 to the power of 32, because they did the same error, correcting twice. Yeah, I was looping, I looped on corrections there. But so, move direction is steep equals east. That'll decide whether or not to put this in 0 or 1. And then same thing down here, except for it should be west. Look at this. I mean, if it works. What? Oh my god, this fucking IDE. Why would you move the cursor? Don't move the cursor. Move the text in relation to the cursor. What line the cursor is on. You don't move the cursor when I unindent. West. And don't do that. Don't go to a new line. If you've still got the thing up, that means that I'm selecting the thing. You can't just demand that I not type the whole thing but still leave your deal up, and then what am I supposed to do? I escape out? I cursor out? What am I supposed to do? Did you not use your own system? East-west. What is the intent? How have you been using it and been like, this is good? So this is the same thing that we were doing there, except for, let me just get this fucking copied correctly. We want north, and we want, yeah, don't find the beginning of that either. Not is steep. Because now we're on the Y, so we're going to invert it. I think this is right. If I'm wrong, then the way that I'll be wrong is, no, because if it's steep, then we're going to write east-west in one of them, we're going to write north-south in the other. So they will always move, dir will always be populated in both places. So this shouldn't implode. It might not work, but it shouldn't implode. Okay. So it's working. Up until here. And then let's enjoy the fruits, or, you know, find out how this still doesn't work. We know where we're going, we know where we are. We know that it is steep. Is it steep? Should be steep. Come on, baby. Wake up. True. There you go. It is steep. So we just set 1 equal to east instead of 0 equal to east. So its move direction is now none east, and then it's going to be south. So it's going to be south and east. Now the idea is that for each like normal move that happens every single time, it's going to be moving the direction that's in 0, which is now south instead of east. And so every time that it wants to move, it should all the way there. But that's on a range of 1. The range isn't right now, because we're going from the range of x1 to x2 in a negative direction. Okay, so we're only going to move once on the south, is what I predict. We moved once on the south. And then I'm going to take this back out and... So it wasn't right. It didn't operate right, and I know exactly why, though. For the next stream break, can we hear Stick It to the Man by Superbomb? I could find that for her. We should take a live stream break. I want to finish this up. 3 hours on Bresenham. So now the issue is here. Stop. Now the issue is here. In that our range is x1, x2, ix. We need the range to be the number of steps. And I don't think we need to do this ix horse pucky bull noise. We just need to know the number of steps and have the move directions correctly. It doesn't matter whether we're going forward or backward here, because we're not using the xy. So we don't need that kind of a range. We just need to know the number of steps we're supposed to take. In the steep instance, we need it to be whichever is longest, basically. We need it to be whichever is longest, which number 1 means that we don't need ix at all. Look at this. And then in here, whichever is the longer side, yeah. So I can just do, the range is, I guess I got to do it in this longhand, so if, dx is greater, am I already doing, like, dx comparison somewhere? No. No. Yes, for is steep. So we use is steep. So iter equals dx, and so the idea is if is steep, iter equals dy, else iter equals dx, which would be lovely if we had the ability to just put that in line in here, because if we did, then this could have just been, this is why it took me longer to think about it, because I'm so used to saying something like dy if is steep, else dx. That can just go in there in regular Python code, but not in the game. So we've got to define it as a variable and pass that variable in. I'm going to take that out. I'm going to put you here. Stylistic choices now. Okay. I think this will work, and then we can go to a live stream break after 3 hours of Python coding. That I thought this live stream was going to be, a little bit of this, then we'll get over to cluster truck. Something might be wrong. I might have broken something. How? It should be the abs. Number 1. Right? We need a positive integer. But yeah, that still makes sense to me. Is it just that, like, why would... Okay. It was just that it wasn't a positive integer sometimes, and so sometimes it iterated not at all. It was like, do it -1 times, and it was like, you mean 0? I can do 0. Here it comes, though. It should come down here. It didn't come down there. Son of a fucking whore! It's the same... It's a lot less code for the same result, though. The same broken result. To end up over here. See, the thing is... Well, let's have the live stream break. We'll come back and we'll bang it out real easy after the break. I will definitely solve this after the break. Just a couple of seconds away from it. Off by 1, like, the fact that it's going... It's going in both directions every single time still, which is just not the thing. Which maybe just means that the error is accumulating when it shouldn't. Because I think everything I've just done is rock solid, airtight logic. But maybe the error is... The error is assuming it's adding dy and dx specifically. It's making assumptions about which one is which. And we invert them. So yeah, this needs to flip to dx when we're, you know, absing. Dx and dy do need to flip. Alright. Let me try that. Let me let it get its big pumpkin first. There you go. Alright, stop planting. So I think we can probably express this a little bit better. But... if it is steep, then dx equals dy, dy equals dx, but we need to flip them. Temp equals dy, dy equals dx, and then dx equals temp. Right? Something like that. Just to try and hack it in there. In the case that it's not steep, then the assumption of directionality is correct, and it shouldn't be a problem. So this should just work the way that it's been working. Only when it hits steep, what we're expecting to see is that it moves over by 1 and then just comes straight down to here and keeps going. Because there should only be an error of 1, and then come on down. And if this doesn't work, then we're going to live stream break. There you go. Got it. It did it the other way. Went down one and then over one to the right, but there you go. Got it. We will figure out a way to do this in a way that doesn't suck, that doesn't look that nasty when we come back from the live stream break. But it's running. It's running, and we managed to, in just 3 short hours, get Bresenham's formula, which can be expressed in like less than 10 lines of code usually, working, to no particular benefit, you know, no major benefit. I just thought it would be fun. Did we have fun? You have accumulated a lot of unlock points too during those 3 hours. Yeah, we did get, we got some crops in, didn't we? We've got a lot of pumpkins sitting around. And wood. Wood and pumpkins, many. We could use some more carrots. Wheat maybe also. We got there though. We got there. And I feel like I could have saved about 2 hours, 45 minutes of that hassle if I wouldn't have started with somebody else's bust-ass, broke-ass, nonsense goddamn formula from first Wikipedia and then from Rogue Mills or whatever the fuck that site was, and Geeks for Geeks also had like their own version of it that was like, but this only works when the sun is in alignment with the rings of Venus on Jupiter house Saturn. It was bullshit. It's as bad as trusting AI, trusting people on the internet. AI is just a new person on the internet, but that a lot of people unnecessarily, you know, have decided to trust. But nothing has changed about the scenario. If you go to the internet to get a fact, the fact that you get back is likely to be in error in some way. It'll be 70 to 90% true. But that 30 to 10 can have a real big impact. God damn that pumpkin! I'm sitting here waiting for that pumpkin so that I can go to break, not feel like I'm still waiting for that pumpkin. I'm waiting for the pumpkin, then we'll go to the live stream break. I might need to go into an even duller, like, just a less powerful color on my eyes here. Get that pumpkin this time around. Next up, spotting the broken pumpkins. Something I gave up on doing in this game. Only got to this stage too. Oh yeah? You've got this game too on Licensed Streamer? There we go. Giant pumpkin. Now I gotta wait to see it popped. I didn't just... I gotta wait to see it popped. I wasn't just waiting for the pumpkin. I do have, like, multiple other ideas on how I wanted to optimize code today. That I just figured we'd already be done with by now and we'd be playing Cluster Truck. But there will be no Cluster Truck today. It's an entirely, farmer got replaced day. Pop that pumpkin, bitch! Yeah! I love to see it do the diagonal. That is 3 hours just to get this thing moving on the diagonals. Alright, I'm gonna put it into the background and leave it running. So, I'll kill the audio. I will switch to... Oh, wow. I will switch to windowed mode so that I can minimize it on my screen. And, yeah. It's back there, it's still collecting. It's still harvesting on our behalf as we go to 7-minute live stream break. There was a request in chat for... Stick It to the Man? Is that the one that you requested? Unlicensed Streamer? Was it Stick It to the Man? Or did I just come up with it? It is Stick It to the Man. I think probably the fastest way is for me to actually just open that folder and search for it, because I don't know how easy it is to find in AIMP here. Yeah, I'm gonna go find it. So, on the D drive and the videos thing, and then under resources, stream music, mine, Stick It to the Man. It's not in? I don't have it in the list? I don't have it in the list. Superbomb Detroit, Bandcamp, album Superbomb. Any way we can, we would stick it to the man. They threw the bucket up. Did I play on that one? That was Superbomb. Didn't involve me. That was Brandon and Greg and a guy whose name I never met because I was never in the band. Did I play on Stick It to the Man though? God, I know the song like it is mine. So I must have. Wait. I'm gonna go find my my super deep backups. Okay, I'm gonna search. No! Am I just not on? I might just not be on. Holy goddamn hell, what? You don't care about my privacy. Alright, well this is Stick It to Man. Meet me back here in 7 minutes. Don't go anywhere, Paul, not out.
We can day the whole world went away.
Whoa! Hello, I am the Ronan Bone, and welcome back to twitch.tv/Ronan Bone live stream on twitch.tv/Ronan Bone. Yeah, I was very confused by that. Like, said, can you play the song by Superbomb, Stick It to the Man? And I fully believed for a minute, yeah, that's one that I drummed on. Because I know Greg's music as well as if I was all of them. And no, that's Superbomb. Superbomb was Greg and Brandon Fry, my buddy Brandon, and Greg Aubrey, and a drummer who I wasn't involved in the Superbomb project. Right? Right? Am I crazy? Like, why don't I? Yeah, I don't remember recording "Stick It to the Man." I don't think that's my drum line. I don't know, man. It's just, I've lived a lot of lives, punk rock drummer for various bands over the course of 20 years. I'm pretty sure Superbomb was not me. Welcome back to the live stream. We're doing The Farmer Was Replaced today. And I just need to put me back into full screen, get us a little bit of audio back in here. Yeah, let's say about a 0.2. Maybe a little bit more. Put it back to where it was, which was more like a 35 or something, I think. Yeah. Okay, so we just got Bresenham's Raster line formula working after 3 hours fighting it, because I kept relying on somebody else's code, and somebody else's code was always, like, broken or set up to only work in a certain situation, or... and then I just had to ultimately write it myself. Figure it all out, completely reverse engineer it, come to understand it again, and here it is. The last thing that we did, though, is I just hacked in the final solution that needed to be in here, which is in is steep. We needed to be flipping the dx and the dy, which we can do a lot easier, and I can actually, like... What if we just pack the dx and the dy to a list and then reverse the list, if we find that it is steep? That's what I'm saying. And then I don't gotta do anything special. Yeah, let's get a new window for that. Let this thing pop its giant pumpkin. So come on over here. And so we got the is steep, abs dx dy. Instead, what if we pack to a list and we say, See, dx and dy, maybe it's standing for the distance of the x and the y. I'm going to say length. Maybe even lengths. Lengths is equal to, and then we're going to pack these values up to them. So here's your x, and here's your y. Thank you. And so we're packing what used to be dx and dy to that. Maybe I'll just say d's. Because it opens up for a lot more. Alright, d's nuts for a lot more fun. So we just switch out wherever dx and dy were before. I feel like we don't even need to do the is steep thing anymore necessarily. It's fine. Iter equals abs dx, if steep, iter abs dy. So actually now we can just say range is the absolute of iter is steep, right? Because is steep indicates whether or not true or false, which is also 0 or 1. And we want to use, you know, if it's whichever one's longer, if it is steep, then that's value number 1. If it's not, then it's value number 0. And then here where we're using the abs of dy, we just use the d's, and we use the d's from is steep, not as steep. It'll be 0, so it should be not as steep and is steep. And then you are d's is steep. That tightens the code up a lot if that actually continues to work, and I can't be asked to give a damn about losing crops or anything like that. Does it work? You're saying I've got an error. Something's not a valid expression. I needed another... Oh. Hang on, I didn't actually bring the code over. I just started without bringing in my new code, which is this. And then, And we've got the error. Iter has never been defined. Right. I don't need the iter. I need the absolute of d's nuts. Have you seen d's nuts? We'll delete this. Can I get rid of you? I think I can get rid of you. I can get rid of you. Okay. Just gonna push you off somewhere where we don't have to think about you. Even though this doesn't really make sense. Something like that. Fits on screen a little bit better, I think. Okay, that does seem to work. So to have a quick review of the code without staring at the flashing nonsense, and without turning it off, because turning it off is also a problem in the long run, let's just look at the code and see if there's anything else that we can clean up or want to clean up here. So we've got we get our actual position, we pack that away, we just take these values and we turn them into the x2 and the y2. How many times do I use x2 and y2 in here? Because I would love to just get rid of this line. So let's do that. And let's say, instead of x1, y1, let's say cur x, cur y, like we did before. Like it used to be. Remember how it used to be? Cur x, cur y, And then you are dest x. You are dest y. And then if the cur x is less than the dest x, if the cur y is less than the dest y, and then is there any more use of them? No, I don't think there is. Can this be consolidated any? If cur x is less than dest x, then it's whether we're setting it to east or west, and we have to, it's breaking on... What if we just packed it, okay? What if we packed it? So, like, the directions... Well, it's based on whether or not one is larger than the other, so we have to do that test. There's no implicit way of finding that out. That cur x is less than dest x. We compare the ds,y's, but we need to, yeah. So I think that's necessary. I think the move direction stuff is actually necessary. Alright. No, I like it better with the space in there. So we set up the initial conditions. We rotate the line if the line travels vertically more than horizontally. We rotate line consideration, let's say. Line consideration. If line travels vertically more than horizontally. Pack it all up. And then down here... Bresenham's rasterized linear algorithm. Which is really churching it up, by the way. That's the look at how short that little thing got. It fits into just a few lines there. It is back down to like 10 lines, you know? It's more than 10 lines, but don't look too hard. Yeah. Alright, so now that's the version of the code that I want to save. So, should I wait for you to produce big pumpkins? Is that one gonna be good? Okay, you got a big pumpkin, I'll wait. I'll wait! I'm so surprised, I thought you were the drummer on Stick It to the Man. You have played it for years on this channel. Have I? Anyway, we can stick it to the man, throw the bucket up, because I think I just liked that song so much that I played the hell out of it on the channel, but I don't think it's mine, yeah. I just think that's a really good song that Greg wrote. No, stop. Stop, and then go again. Down here. What? You have an error. It's your error, not mine. Okay, it's because of your goddamn snake case. No, this one. This one starts here. Okay. Now I can get rid of you. And we're back down to the code. Lovely. We have good running code now. The next thing that I wanted to handle, I don't know, let's consider this. There was another thing with movement. And it would be lovely if, instead of going to the beginning of every line, we just went back and forth. We've written an absolutely wonderful move to function now, so let's not use it. Is basically what I'm saying. Let's use less of it anyway. And the idea is I could just keep a temp, keep a temp file open. The general idea here is when we're just doing simple movements right to left in the plant area thing, why are we using move to? We don't need to be using move to, okay? Once we get to where we're going to be, we know that this is a square area. It's an area. It's got a width and a height. So we're going to go left to right and up to down. So my idea is, to move us to the start position, the original start position. So, like, before anything happens. Nando? What the fuck? Plant area. Before anything happens, move to the start X and the start Y. We were doing it implicitly before. Now we're going to specifically say, get to this location to get started. But then after that, we're not going to use the move to function anymore. We're going to traverse left to right very simply, and it reduces a lot of the unnecessary, like, overhead as well. Like, why are we running this complex, Bresenham algorithm when we know that we just need to move, you know, in a row? So for X in range width, we've gotten to the place that we want, so we're going to do the thing that we do, and then at the end of it, we're going to move to the east or the west, depending. So, we're always going to move north. When we get to the end of it. But the way that I think I'll do this then is I'm going to pack up another value, and it's going to be direction equals. I mean, I could do it in an if statement, or I could do it implicitly. Let's do the if statement. If the start Y, because that's where we're going to end up landing. We're going to go to start Y. So if start Y mod 2 equals 0, then move dir equals east. Else move dir equals west. And the idea is, if we're on an even row, okay, because that's what mod 2 does. It tells you whether or not the number is even or odd. So we're going to go to the column, which will be 0 to start Y. We're going to go there, and we're going to say, is this even? If it is, then we're going to move east every time. And then when we get to the next row, we're going to consider again, is this row even or odd? And if it's odd, then we're going to move west. That's going to allow us to do this instead of going We're gonna do a back and forth raster movement. Now this can't just be this can't just be at the top. It's not an instantiation. It has to happen every time that we change rows. So it would happen here, and it wouldn't be on the start X now, it would be on the Y. God, ballsing, shitting, damn it. So it's not start Y now, it's on, for Y in range of height. So you don't actually know your location at this point. We've moved to it. So we could do a get pos Y. If get pos Y 2 equals 0, then move direction equals east, move direction equals west otherwise. And so that should allow us to go, and then we move up, and yeah. So we're going to move in the move direction at the end. So we do the whole row, when we get to the end, we move up by 1, move north, and then when we loop back through, we determine whether or not this is odd or even, and depending on that, we can go the other direction, go the other direction, go the other direction, until we reach the very top of it. And so we only call the move to thing at the very beginning. This is where we retraverse the whole deal to do a plant when we find out that we need to harvest. Here's the thing that we could do. Before we move, we could check if we require full and are ready. If we require full and we're ready, then we can just harvest and carry on with our lives. That's a way to simplify this code quite a bit. Right? I just pull a harvest right there, and then we don't head back and replant. It's downtime for the field. It's a lot of downtime for the field. How about we just recall ourselves? Plant area. And then we pass the same crop that came in, the same start X, the same start Y, same width, same height, and then require full should still equal true. We just call ourselves. Now this creates the possibility of like infinite loop recursion kind of stuff, because you're calling yourself from within yourself. But this will never be instantly true with pumpkins anyway. If it is, then we can, you know, we want to harvest that immediately if it all managed to grow in the time that it took us to, you know, that kind of thing. It'll never be true though, because we plant and then we haven't actually, every time that we plant a crop, we're no longer ready. So it will never be and ready. It'll never be and ready at the end of a process, and then we don't have to do this anymore. We don't have to do that anymore. It can't be done here. It has to be done at the end. Yeah, it has to be done after this, which becomes... That makes a problem for our movements. Yeah, that's brilliant. That's good work. Good work on the IDE portion of this. Yeah, this becomes an issue because we always move. So we will have moved one. We just don't have to harvest. We can just do that. See, my brain was telling me, wouldn't it be nice if when you get to the absolute end of your checking, you broke it immediately. You broke the plant there, and then, you know, go back and reseed it. But we don't have to do that. If we require full and ready, we just call ourselves again, which implicitly sends us to the back, and we do the harvesting if we can do the harvesting. Yeah, that's fine. Your move to diagonal code is good for broken pumpkins because they are random, and you can scan for them, as I recall. We end up being able to scan for broken pumpkins, huh? I mean, we could just, like, traverse the whole field really quick, and... I mean, aren't we already doing that implicitly with plant area? I think we are. Anyway, I think this is code that's worthy of testing now. This should introduce the idea of raster, like, reverse raster, you know, movement. So we move right and then go up and move left and move right, and so there's just that little bit of time save. I'll wait to pop the big pumpkin before I interrupt. But I will be ready to interrupt. See? Scan, 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 scan. There we go. Alright, well, let's try this. See what kind of bugs we get. Kind of error. That's not the one. That's the one. Okay. Okay. So, I've introduced a bug. A slight bug. Because we always move... Even at the end, we move in that direction. So... How does this work? Move direction equals west. I guess I could throw in a, move direction only on the west, and that would keep it running. I don't like that it's a bit uneven to do it that way. Ah, god damn it, it's this one. But it should... No. No, see, it continuously, like, it gets us further and further along as we go, so that ain't it either. Kinda good, because I didn't love that that was a thing. But I could wrap the mover in an if. And then what would the test be? Let me see what the movement is again. From the beginning. See, so at the end of every one, we still do the mover to the east. And we still do the mover to the west. The mover to the west puts us back where we want it to be, but if we were here and we went up instead without the mover, and we do here, 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 and then we move up to... So yeah, if I wrap this in an if, that'll solve it. And then we can think a little bit more critically about it. So it would be like, if... x is equals width minus 1, then... Or no, if x is not equal to width minus 1, then do the move. Does that get it back up and running anyway correctly? Yes, and we've got the back and forth that we were looking for. And then I think we can probably come up with a way to do that that's a little bit cleverer than that. More implicit. Okay. So, slight problem in finding... We went up as well, so actually both of these need to be, like, prevented from this happening on the last one. I mean, we'll think about it, like I said. We'll be smarter about it when it's time for being smarter about it. This is not going to go up here. No, it went up there just fine. There you go. No. Where did you think you were? That's so weird. Because it should be, like, operating on a like, it gets its actual position. It shouldn't be confused about where we left it. Oh, we asked it to plant on a... to start planting on the wrong row. Aha, ha, 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 ha. So then we actually don't want this to be based on your get position. Wow, we've already got a giant pumpkin. I will let you collect that. We want it to be based on where you started. Wherever you started, you should always go to the right. So that's good, because we're operating on widths and heights already, and uh-oh. Okay. So we found another bug that I can fix real quick here, which is if require full and ready plant area. So we are going to do a harvest. And then plant area, and that should keep us running. Apart from the carrots, it looks good. Yeah, we're real close to having it working again. And it's really just down to the fact that I did this based off of get pause Y instead of just Y. If we just do it off of Y, then it'll be wherever we started will be considered, you know, that we should be moving to the right to start, which is correct. We start at the lower right of these areas, so we should always be moving right at the beginning of every area. I actually, that was what I was thinking to do in the first place, and I was like, you should do it off of the world position. I talked myself out of the correct solution in my head. Yeah. The next, incredibly clever thing that we could do is actually make it so that it can fix this on the fly. So we do go back to using get pause Y, but when we see that an area starts on a row like this, then we automatically change our starting position to its bottom right corner instead, and that would not waste any time. That's what I want to do. So let's continue our development down here. So we do actually do this on the world position instead of on our starting position. So get pause Y. Right. So in the event that it's an odd number and we want to be moving west on it, this still assumes a certain thing. The smartest way to do this would be to go to the nearest corner of the field and start planting. But then we'd have to be able to plant in either direction. North, south, or east, west. We'd have to have enough logic here to handle choosing the direction of planting instead of just operating on a width. Well, we just set the direction, is the idea. Let's write a little function. Find corner. Okay? In fact, I will call it exactly what it is. Find nearest corner. And then what we pass to this is a bounding box area kind of thing, but we'll pass it all as you know, numbers. And I like XY width height. I know that it involves some conversion and people don't like to do it, but it's so much more intuitive to use XY width height than X1, Y1, X2, Y2. That's a math guy thing. We're coders. This absolutely is the way to go. XY width height. So we're passing in, that's how we express our bounding box, is it's going to be, we've got a rectangular area, starts at XY, and apparently that's going to be the lower left corner, because that's how things are expressed in here, and then we got the width and the height. Yes. So to find the nearest corner, we get our cur X, cur Y, equal to get pause X, get pause Y. We could write a little helper that does this. that just returns this at this point, since we use it so many times. So we get our current position, and then we need to figure out what's the closest corner here. So how do we do that? Like, this is the kind of thing I would just hand to ChatGPT. Because there's a known solution for it, it's an algorithmic thing, and it's actually quite clever in a way that you do it on the computer and it saves a lot of computational time. Like, this is the kind of thing that it's already been done. But if we're gonna do it, like, from our own minds... Hello, El Gavo. I feel like I'm going to do this the way that I would do it, and I'm going to bring it to ChatGPT, because it's just a waste of time for me to do it otherwise. Yeah. Yeah, it's a huge... It's a lot of... It's a lot of me sitting here trying to reinvent the wheel, and we don't need to reinvent every wheel. I'm going to get rid of that, and I'm going to get my, my true browser open, which is LibreWolf, by the way. I close it down for the live streams. You guys will not be able to see it. What? Hello. ChatGPT is... their website, OpenAI's website, is shit. It is awful, it is broken, it barely functions, it's slow as hell, it's like... Everything about this is utterly... disgusting. They can make a... Like, this is why I don't trust them with, you know, artificial intelligence. They couldn't make a fucking website. It's a chat room between you and one other person. They can't make it work. Fuck these people, right? Alright, so... I'm on the live stream right now. And then I'll in parentheses wave hi to the I'm not going to show you what ChatGPT says back. Wave hi to the audience. We'd like to I'm playing a Python coding game, and I want to find the nearest corner of a bounding box, given my coordinate position on a grid. The idea is to go to the nearest corner and begin raster operations from there, so as not to waste time typing a bunch of stuff up to the AI that it doesn't necessarily need to know on a live stream. So as not to waste time traveling to a certain corner, lower left every time. What's the algebra for something like that look like in Python? And there we go. You recommend Brave browser, which I now use. Why did you change browser? I got a little... It started to feel heavy and bloated and slow, and I didn't like the fact that it was built on Chrome. On Google's Chrome. I know that it's been, you know... But it started to feel a certain way, so I switched over to Firefox to see how that felt, and Firefox felt a lot like snappier and lighter, and boom, 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 felt really good. And then from Firefox I moved to LibreWolf, because LibreWolf is Firefox, but it's a more secure version of it, and then I customized the hell out of LibreWolf to the point where it's a little bit more like Firefox, and a little bit it's very much in a certain space now, the way that I've put everything together. But it was the same sort of like privacy and, you know, feels good. I wouldn't necessarily recommend LibreWolf just because Firefox is less supported. which sucks. Like, in fact, I do recommend Firefox, and I do recommend LibreWolf, because I feel like there's a concerted effort by Google to really try and corner the market with Chrome, and because of that, like, they make it so that CAPTCHA, you know, Google provides those CAPTCHA services that do your security testing and stuff like that when you go to certain websites. It drastically prefers a Chrome browser. Like, you rarely get asked about your CAPTCHA in a Chrome, and you get asked about it a lot in Fire. You end up having to pick the fucking fire hydrants and shit a lot of times in Firefox. It's very annoying, but it's because Google is a corrupt organization that, you know, long ago took the do no evil part out of their slogan. Totally dedicated to spying on you and using that information to sell shit to you and manipulate. You know, it's like, I do keep a ungoogled Chromium is my Chrome browser around, which is also inconvenient. All the stuff that I use at this point is now inconvenient because I'm preferring the privacy so much. But I'm on a new level of privacy now. Like, my computer is locked down so that I've got a firewall that blocks anything from going out. There's my my light. This is my light. And I've got it hung, dangling by a string up here, and being held by, like, a bread tie that I just hooked over, and apparently the bread tie gave up. There you go, bread tie. You hang in there, buddy. We got a little bit more show left. Shit just fell on me. Okay. Hey, chat. Pawn's got me...
Oh, shit.
Yeah, the lights are falling out of the sky, Jermacian. What are we doing? We believe in you, bread tie. Hang with us. Hey, chat, says ChatGPT. Pawn's got me thinking fast today. We're doing Python math on stream. All right, here's the clean way to handle that problem. You've got a bounding box defined by x1, y1, top left or min corner, and x2, y2, bottom right or max corner. I'm going to do x, y, wh, width and height, but we can convert to, you know, top and left corner for ChatGPT's sake. And you've got your current position. So you want the nearest corner, whichever the four corners of the box has the smallest Euclidean, or Manhattan if you prefer, distance from your point. Here's how it looks algebraically and in Python. And it's very simple. This is why I didn't want to sit here trying to, you know, do it for y'all, or trying to figure it out myself. I'm not a math guy. So here's what ChatGPT gave us. Yep. It snapped to the bottom, didn't it? Yeah. So, by ChatGPT. So nearest corner, we've got our position, we've got our top left and bottom right corner, and then whether or not to use Euclidean. We've got an option whether we want Euclidean or Manhattan. That's interesting. So what's the difference between Euclidean and Manhattan? We're talking about Euclidean would be the actual, like, linear distance, whereas Manhattan might be, like, grid-based distance? I would expect trying to do grid-based distance would require, like, A-star considerations. What firewall are you using, says Unlicensed Streamer? The Windows firewall. But the trick to making the Windows firewall, like, actually useful, and actually powerful, is Malwarebytes Windows Firewall Control. Malwarebytes Windows Firewall Control allows you to, set the firewall to block both incoming and outgoing, and then the little Malwarebytes application, you have to set the option, which is a little bit inconvenient, but you set the notifications to display notifications, and whenever something tries to go out to the internet, you'll get a little pop-up saying, this program is trying to talk out to the internet, do you want to allow it? And eventually, you will have allowed all the things that you use and that you want to talk to the internet, and you'll never hear about them again. But anything new that pops up, any program you download, any malware, anything like that, that tries to talk out to the internet, it's going to pop up a thing and say, hey, do you want these people being able to talk out? And I have caught so many things. Not like malware and viruses, but it's just like adware, just shit. Shit that's just constantly polling, telling, sending out data and stuff like that. I've shut it all down. So yeah, Malwarebytes, Windows Firewall Control. I didn't know that it existed when I found it and started using it. Oh my friggin' god. So you're using a Lambda operation here. Why? So that you can run it against, it can be considered as a list? Is that the idea? I don't understand exactly how she's doing this. Yeah, there shouldn't be any code here. Try moving it, putting on an underline. I understand. Shut up. I don't care to understand this or this. That's fine. But we're passing into min. I've never used key equals in here. Okay. I'm going to have to get back with ChatGPT on this. And say, if you specifically want the nearest corner, she says, if you want the nearest corner but prefer the lower left corner if distance is tie, then you can add a tiebreaker. Ah. Right. Want me to optimize it for pure integer grid? No square root, guaranteed whole numbers? There's always a question at the end of something that ChatGPT says to you, isn't it? I'm not a math guy. You literally have made an automated blockchain trade bot, a speedrun cheat detector, and an auto splitter tool. Yeah, that's right. And I'm just not a man. When I look at those, formula for math, it's all Greek to me. Which it is, right? I don't know, because I don't give a shit. I'm not interested in your crazy math formulas. But, I know what I need to know. I can make sense of some of Pythagoras. I don't know. What am I saying to her? Specifically, we're playing a game called The Farmer Was Replaced. And it's got its own version of simplified Python going. So I can't use Lambda, and I can't use key equals from min, which I don't even know what key equals in min does. I've never, but, can you give us a version that works with, the basics of Python expressions. Simple basics of Python expressions, yeah. Got it. Hi again, chat. We're going old school here. Bare bones Python style, no lambda, no key equals magic, just pure math and if statements. Here's how you can do the same thing with only basic syntax. A little bit longer here. Completely vanilla, should run in any sandbox style Python game engine. It just loops through each corner, checks the square distance, and remembers the smallest one. If you want it to prefer lower left when tied, like your raster bias idea, add this just below. And then, yeah, she always comes up with, some extra little thing. So here's the version that may work in the game, according to ChatGPT. We've got the corners, we just define them, and then we start with the first corner, nearest equals corners 0. They've all been packed into a list. So corner 0, 1, 2, 3. So corner 0, bestest equals nearest 0, and then we're squaring it. So it's nearest 0, so corner 0, nearest 0, so that'll be the first number in the tuple there. Those are nested tuples in a list. So the first integer in the tuple that's in the list minus pixels. Oh no, minus my position, my current position at px, and we square it, and then we add the second one minus the py and then squared, and it's just basic, basic, what did she say it was? Because I don't know. It's basic, it's obviously, it's just pure math, and it's just basic, good old, everyday, ordinary, square distance. You know, simple, everybody understands how to square the distance of the root of the diameter of the, cubed integer relations. Check each remaining cursor while I is less than 4. CX corners I 0. Okay. Okay, I get it. So this just loops through and does what we did up here. I'm happy with that. I'm happy to trust that anyway. So we really need to break up our code a little bit again, make some more imports and what, because we've got some utilities now that are separate, that should be separate from the harvest stuff. In fact, I could do it that way. I could just go ahead and put you in here, and then if I get rid of all that, okay, and then we'll name this utilities. So we've got our move to thing that we wrote over the course of 3 hours, and then we've got the nearest corner thing that ChatGPT gave us, you know, within 5 seconds of me asking. So, you know. And so let me just adjust this to match like what our actual setup is. We're not going to pass in px or py. I like xy width height. Sorry. Sorry, not sorry. So the corners here are going to be xy, and then top right is x plus width y. And then what do we got here? Bottom left would be x and y plus height. And then bottom right is x plus width and y plus height. And I see that we're doing math twice there. So what we can do is we can do x2, y2 equals x plus width, y plus height, and then we can actually go back to x2 and, you know, back to that original expression form. And we're doing the math, but we're not doing it unnecessarily multiple times, which is called a micro-optimization. And most people are like, why would you do that? Why bother? Because it's good code, damn it. Want to hear the approach I went for in this game, says Unlicensed Streamer? Sure. Slap shit against the wall. Brute force. I mean, I've played, this is my 3rd time playing it. Up to the, like, we got to the point that I had played it to last live stream, so this is my 3.5th time. Starting from the beginning and coming all the way up to pumpkins. I did that twice before. We did it on the last stream for the 3rd time, and now I'm iterating on that code. So, you know, we're at the place where I'm like playing with it and enjoying it. I'm not here to do it the best. I'm not here to do it the fastest. I'm here to do it the way that I haven't done it already and that interests me in the moment. And all this moving stuff is fun to me, especially because I've been thinking in terms of XY width height, pixel grids. I've been doing a lot of image handling. My whole life has been image stuff for the past 3 months in my own Python project. There is no reason to have a comma at the end of that. I also don't like wasted white space. So we can just stop that right there. You can go ahead and do that. if you want to, you know, make it look a certain way. And in fact, I said I don't like wasted white space, so do this. Okay? Get the same effect. Packed into like a smaller area. Why wouldn't you just do that? Dummy. And in fact, I could take that and do like that, and then no. You like that, and then you like that. Huh? I don't know. Anyway, we find the nearest corner. We need px and py to be set equal to our position. So px and py equals get pos x, get pos y. And then everything else is good. Handles itself. It's just the math part of things. Looks good to me. And so what we'll be returning should be an XY coordinate, right? Yeah. One would think. Now what would be nice to know is whether or not that coordinate is the top left, the top right, the bottom left, or the bottom right. Because what we need to know is whether or not we should be traveling south and east to start, or north and west, or north and east, or south or west. So that's what we really want to find out here. So we want the coordinate, but we also want the tuple of directions that we should be heading in to start. Is that right? I think that's right. And then we just alternate. We just keep flipping the direction when we get back to the move code. Yeah. Or when we get back to the place area code, we just flip whatever direction we started on when we get to the end of the row. Yeah. So we need the tuple of the two directions that we want to be going in when we get there, which means that we need to compare what we found against the corners that we established in the first place and hand out the associated directions. In fact, what we could do is pack that data in. Keep it separate. So directions equals, and we're gonna do again something like this. So if we're at the top left, in fact this is inverted. She was thinking in the same coordinate space that we always think in, but it's bottom left, bottom right, top left, top right. I'm not going to stop referring to ChatGPT as she in this moment. It's just not going to happen today. I did this like a printer. 4 loops to define how long a crop should be planted. And using the Pac-Man physics for line shifts. Your method is good at being dynamic, so it can handle adjustments to game field changes easier. Yeah, I'm not considering the Pac-Man stuff at all, am I? I'm not really using it anymore. I've gone down a certain hole, that's all. It's not a better hole, it's just a certain hole. Put you out there. Yeah, you went like full raster printer style. So if we're at the bottom left, then the directions that we need to be traveling in are east and north. And then bottom right, we need to be traveling west and north. And then if we're at the top left, it needs to be east and south. And then top right, west, and south. Yeah. And actually, I'll just leave it like that, because then we could do this again. I don't suppose I can... Bottom left. Please, please. This is just awful. How do I get out of it, and how do I keep going? I hit escape and it exits the fucking thing, and if I don't... If I'm just typing my own thing, I guess you hit space at the end of it? Is that the intended mechanic? Like, always hit space to end a thing, and then back it up? There you go. Okay, so that gets us the directions that we want. And so... have I got this right then? Like... shoot. Orders, we'll call it. Orders equals directions 0. So we prime this stuff. In fact, let's do it like this. Nearest and the associated orders with that. Like that. And then nearest. This is a little bit weird though. Why is CX, it's I0, I1. Like, you're breaking it out. Why are you breaking it out like that? Why don't you just do CX, CY equals corners I, number 1. Okay, express it, you know, like we've got a brain. You can, if you're unfamiliar, it's not because you don't have a brain, it's because you're unfamiliar, but, like, you unpack the 2 values that are stored in the tuple into 2 individual variables like this in Python. You don't have to say equal to I0, equal to I1, and then that tells me that if this is correct, nearest is equal to CX, CY. Why are you repacking it? Why aren't you just saying corners I? Like, she's unpacking CX and CY from corners I, and then she's repacking them to ship them out. No, it's the same values. You don't need to do that. And honestly, you don't need to define CX and CY at all, because we might as well do corners I, 0. If you're only going to use these values once, there's no reason to unpack them into the local space like this. Except that it becomes more, it's more legible. So ChatGPT often writes in a way that's legible so you can understand it, because how could you possibly know what's happening? Why are we doing this with a I equals 1 and a while loop instead of a for loop? ChatGPT must have been really nervous to be on the live stream. Because, am I crazy here? What is this? For I in range of length of corners, which we know to be 4, but I'll do length of corners. No, I won't. I'm going to say range of fucking 4, because that's one more operation we can take off. For I in range of 4, and then you check all of the I. Oh, except for she starts at 1 and then goes, so 1 to 4. It's because I told her that it's a simple thing and she was trying to avoid using for loops or something. Like, that's gotta be the only explanation for why she wrote it this dumbly. You don't need any of that. Look at how much code we've just gotten rid of. Nearest orders equals corners I. Corners I, and then directions I. Alright, and then we ship out nearest and orders. This is what we return. best dist equals dist. When did best dist get set? If dist is less than best dist equals, so we primed it up here. Yes. I see. This doesn't need to be this way either. We can just do range of 4. Right? Can we? I'm not gonna mess with that. I'm gonna stick with what she's got here, because if I keep trying to fix it, god damn it. I keep trying to fix it all. Eventually we'll get to a point where I've broken it instead of fixing it. In programming, there are many equally valid solutions. In games, the fun solutions are many. Yes. So, I think that nearest corner thing probably works now. It's probably what we need for this game. We can test it. So let's get rid of buy ChatGPT. Because we've made our own version, and I can always copy it from the web browser if I needed it back in. I'm gonna shut you down. Unless you grow a giant pumpkin right now. God damn it. I was gonna shut you down. Alright. Do it over here. So, from utilities, import all, and I'm gonna get rid of our move to function from here. And that's how things are gonna be. Okay, wrong one. Actually, stop before you plant a whole bunch of stuff, because I also wanted to insert a test of our, what's it called? Nearest corner function. So, every time that we go to plant an area, I want to print the return of nearest corner based on the start X, start Y, width, and height. Okay. And go. Go. Huh? The imported module is a syntax error. What did I do? I didn't close you up. Need an extra parenthesis there. Okay, it looks like it doesn't print stuff like that. Oh no, it did. Okay, it did on the second pass there. Good. So we've got east-north, 0, 0, and then east-south, 6, 3 would have been the closest. Right, so here, this would have been the closest. Which is 6, 3, yes. And then from here, when you got to the end there, 12, 3 would have been the next, except for it's 12, 4. Well, 0, 1, 2, 3. Yeah, no. You're right. But then 6, 3 wouldn't be right then. 0, 1, 2, 3. It should have been this one. Okay. So we did catch a little problem here, and it's a, I think it's a range problem, because we're doing widths and heights. 0 plus 3 equals 3. 0, 1, 2. It should equal 2. And so what we want to return in terms of the nearest is I want x plus width minus 1, actually, is what needs to happen. Minus 1, minus 1. Height and width need to have 1 taken off the top of them to conform to our count by zeros standard. So, again, fire it up. So 0, 0 east north was the closest. Get to the end of this one, it should be 0, 0 east north again. It should be right there. 0, 6, rather. And then this one should be this, and it should be 6, 2 would be the nearest corner. And it is 6, 2. And when you get to here, the nearest corner should be 11, 3. Yes, good. When you get to here, the nearest corner should be 6, 6. Oh no, you were at the end here, so it's 11, 6. You're right. You're right. So now we do have the ability to find the nearest corner. And then, actually, we would have started replanting here at 5, 5. Oh my god. I love it! Because it'll always be at a different spot. That's so fucking... If we were to... We get to the end of planting this, and we would start planting here, and we would go like that. So, and then the next thing we were supposed to be planted is there. So that would be the next nearest corner would be to go to here. So we end up losing time eventually. And then it would go to here, and it would go like this. And then it would have to come up to here, and do this. And then it would just jump to there. So it finds a completely different path based on this after its first iteration, and some of it is wasteful in comparison to what we've been doing. Is it though? I mean, we start planting a lot earlier, dude, and then we come up to here, and so we don't waste anything. We just get there a little bit differently, and we save something, right? Like the time that we saved not traveling these, we pick up. We save the time not traveling these, and we spend it traveling back up to this one, and then you get to here, and then you immediately start planting that one, which is the way it's always been. So that's no change. And then from here, this is closer. Instead of being all the way over here and coming back from here, you get to come back to here. I like it. It's kind of crazy. How does your full pumpkin is done code work? Asks unlicensed streamer. It is down to just a Boolean. We pass over every single one of them. If we had to plant anything, then we mark our Boolean, which tells us whether or not the entire field is ready to plant. So we start out true, and it's called ready. Ready starts out true. If we plant anything, it gets marked as false. And so if by the end of the entire field that we've just flown over, we're still true, then that means that the field is ready to harvest. So doing it a very simple way right now. Just iterating the entire field, not keeping track of like which of the ones that we need to, we need to keep looking at. No internal map of the pumpkins, just simple Boolean check. Our function definitely works. Our nearest corners thing is working. It is doing what we want it to do. So that's cool. How shall we integrate it? Utilities. I need like that. And I don't know, I'll put you here. Oh, you don't snap to these things because you're not a code window. Interesting. Maybe I'll put you like up. Something like that. Yeah. Okay. Give me a new code window. And put this in here. Because now I want to use that nearest corner that we just wrote to actually, like, decide how we travel. So, when we pass in this, we run nearest corner, we get back the value that we want. So the way that this is going to go is start X, start Y, and then we're going to need 2 new values for directions. Well, I was already packing those, weren't I? No. So let's say move horizontal and move. That's not going to work. I can't unpack them that way from harvest corner. Not the way that it works now. So I could adjust it so that its output isn't tuples. I'm gonna say, moveders. Yeah, moveders. Okay, so we've got the starts and the moveders will come out of there, and then we need start X, and start Y now need to be equal to starts. We have to unpack that. The moveders, however, we're gonna change how we move here. Sorry? We're going to change how we move here. So we don't have to decide how to move anymore. We find that out from the moveders. So for action range, if X is not equal to width minus 1, move. Okay, let's unpack this as well. Let's say, so move hor and move vert equals the moveders. I should probably just make it so that it passes 4 across, but let's not worry about it. So if it's not the last one, then we want to damn it. What I need to do at this point is I need to flip it. I need to be able to flip it. So if we get back east, then I need to be able to flip it to west each time that we do this. And so the better idea here would be to have move whores and move verts and have them be equal to east west and then north south. And then what nearest corner should pass back to us is actually like a 0 or a 1 for each one of those. So it's just passing a Boolean. Yeah. And that will allow me to flip back and forth between them. So then the code down here, if we were getting a Boolean, would be move whores, what's like an expressive way to put this? Sorry, I'm doing a lot of internal consideration right now, and it's not just about the names. I just kind of drifted off on that. Was the last thing you heard, but my brain went off to a number of other things, like, what about this, what about that, what about the other thing? Move, and then we say H-ter, it's the horizontal direction. And then the idea would be that h'ter is equal to not h'ter. We flip it. Okay, so every time that we use it, we flip it. Wait, no. We flip it on the y's when we do that. Yeah. So h'ter is equal to not h'ter. Meanwhile, you just move move verts feeder. Considering that, let's just do it without, like, changing this and without creating, like, nested stuff. Now that I realize I only have to flip one of the directions, we'll just do it with an if check. If what we got back, and we were going to unpack it before, so it's move hor and move vert, is equal to move ders. If move hor is equal to east, move hor is equal to west, else move hor is equal to east. And so that'll just flip it every time. It's one if check, and then it sets it. It's fine. And so that'll flip it. And then we just move according to the move hor. And we instantiate it like that based on nearest corner. So we'll describe what we're doing. Get nearest corner and instantiation directions. And then all this stuff, the movement is still does what it used to do. It just does it these ways, and then move verts is not a thing. Move verts doesn't exist anymore, so we do move vert. Yes. And that should actually just work out of the box exactly the way that we've already got it coded, I think. Except for the error. If move hor is equal to east, it's a conditional, not an assigning operator. We've got a giant pumpkin we're waiting on, so we will continue to wait on it. Okay. And now, I also do want to take that print out. Did I? Looks like I did. Let's see if this runs. It's getting a little wild. No. It also went in the wrong direction. That's interesting. We were getting the right numbers. I think maybe one of our values is just wrong. I mean, if you're at the top left or the top right, you need to be moving south. If the top right or the bottom left, you need to be moving north. Or, I mean, the bottom left or the bottom right, you need to be moving north. But it went to the wrong square. Too. The first time that it did that. Yeah, things are getting crazier the longer it goes. Start it again for me. I want to see, I think it got to here and it went all the way down to here instead of going to here. It should have gone to here. It should have gone to 6-2. But it went to 6-0. It went to 6-0, and then it went north immediately. Wait a second, what? Remember that print I said? I don't want that print there anymore. I need the print here. Print starts and movers. Need that back. I need to verify that you're still doing what you're supposed to do. You still get the numbers correct. So those numbers, by the way, we've got up here. 00 east north. No, 06 east north. Now 62 east south. But you didn't go to 62. So it got the right number. 6-2. And then we saw that it went here. And then it said its next number, nearest corner, was 11-5. Which should be there. But it went here. So the move must be wrong. Like, what is... These are square areas, so we're not seeing a problem with them? Maybe? Why is the movement wrong? So if y is not equal to height minus 1... if it's equal to east, we flip it to west. If it's not equal to east, then we assume then it's west, so we flip it to east. We're moving on the move hor. We're moving on the move vert. For y in range of height, and for x in range of x. Like, we're just passing move to start x, start y, though. So, if it's not getting to the right place, then that's the problem is in the move to code. And how was it not a problem before? Print dest x dest y. Or actually, when you get to where you're going, after you've moved us there, print where you are. Print get pos x and get pos y. And then take out the other print. No, we can keep the other print. Let's just add a little something here that's print landed at pos x get pos y, and then up here print that just print that. That's, you just print it. You just fucking print it. Wrong one. Go there. Okay, 00 east north landed at 00, as expected. East north landed at 06, landed at 06. Six 2 landed at 60. Let's make sure that what move 2 is getting is what we think it is. By printing at the correct time. If I named this main, would you be able to just start it without me? No? I'm gonna tell you? Alright, this always works. Zero 06 east north, always works. And then 60 landed at 60. Aha! Aha ha 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 ha. So it's just being told the wrong fucking place. But the directions are coming through correctly. Explain yourself, Lucy. Because I just overwrote StartX. StartX came in here, but I overwrote it with the values from starts. And it just didn't do that. It just didn't do that. Like down here, it's that. But the values of starts have not been unpacked into StartX and StartY. StartY? There's your problem. It was a typo. I had it as StartY instead of StartY, and so that's why the numbers weren't what they were supposed to be by the time they got there. All these prints and stuff trying to figure it out, assuming there's some kind of deep problem. It was a typo. It was a typo. It's always a goddamn typo. Where are my prints? Where did I put the prints in there? Because I don't want them printing anymore. I had one at the end of the move code, right? This is the plant area code. The utilities. Pull the prints out. I mean, I'll tell you what I'll do, is I'll leave them in, but they'll be quick prints. Quick print. And then you quick print. Typos. I'd love to hear, like, I'm sure there's a, oh, that's the wrong one. I'm sure there's, like, some company, surely, someone somewhere has done the statistic on, like, how much of a coder's time is, lost to different types of errors. Look at this, look, it's working. Look at this! It's taken the shortest path that it can get to whatever field that it can get to, without considering that Pac-Man exists. Without considering that it could do Pac-Man. So it immediately comes down here and starts. Oh, this is brilliant. If we make this thing aware that it can loop, it's gonna be fucking awesome. Because then it would, and it would end up here and it would go straight to there. Wait, no, it's, it comes in this way, it goes this way, goes, so it would go up right there and it would land right there. If we make this thing, if we give the movement code the ability to understand that it lives in a Pac-Man world, and is a material girl, and I am a material, this is gonna be the shiznit. Why do we only plant one pumpkin? Why do we only plant one pumpkin? We harvested. And then we left that grid. We're supposed to, like, replant. That's a weird one. I don't know how that could possibly be possible. I think I understand how it's possible. So my idea is, it detected that the fastest way to get here would be to go to this, which is the end tile. If you were starting from here, where you usually start. It does the test, it pops it, and then it comes up to here and drops one and leaves. So it does the harvest, and then it calls itself again. That's how we wrote it, is if require full stop and ready, harvest, and then call yourself again. Plant area crop, start X, start Y, width, height, require full. Ah. No, like, why would that, why? Why? Because our iteration is based on width and height, it's not based on, like, where we are. So the width and height are the same. Sure, we've changed the start X, start Y. That's an interesting bug. I don't think I'm going to get into it right now. We'll come back to it. You guys can work on it. I wanna address the idea of the Pac-Man concept. Like, how do we teach the move to code that 11 is closer to 0 than 3 is? Can we do that? This is our sort of scrap document where we just work. So we need to, in the calculation of distances. No. You don't have to worry about the calculation of distances necessarily. Well, yeah, we will. We will, but more importantly, I think we need to work backwards from this, is that, no, it's all about the distances, isn't it? So, the easiest way would probably be to re-represent X and Y as, like, what they would be if you kept going. So, you know how Mario, Super Mario 64, they talk about it having, like, multiple dimensions? And if you go far enough in one direction, you land in the next dimension, but you'll appear in this dimension, but you're really over there now, kind of a thing. That's kind of what I'm talking about, like quantum traveling in here is just the idea of 0 is 0, but we're on a grid of 12, so it goes from 0 to 11. So 0 is 0, but it's also 12. Right? So if we add the world size to everything, and then we test to see if it's shorter to get to the 0 or shorter to get to the 12. Yeah, that's how we do it. That's the simplest way to do it. So we get our current numbers here, but before we set our D's nuts, we want to create an alternate version of our destination. So So 0 is 0, but it's also 12, but that means 11 is also -1. Right? 11 is -1. And then how do we do this loop again? Is that going to hurt this loop? Yeah, it's an abs loop. But it's more about the number of times that we go in a direction than it is. Yeah. I think this should still, it'll just work itself out maybe, hopefully. So how do we do that then? We create a dimensional portal of 3 and we figure out which is the nearest one? And then whichever is the nearest to our current location. Yeah, which means the nearest corner utility that we wrote needs to actually be broken into nearest and nearest corner. So we need a nearest tile. Nearest tile. I wonder if we can pass in, like, args. I don't think we're gonna understand args quargs, huh? So, nearest tile, but the idea would be nearest of any number of tiles, right? So we would take a list of coordinates. We would take a list of coordinates. Coord list. Everything is doing this get pos x, get pos y stuff, and I would make it so that you just pass that in, because again, micro optimizations, but so cur x, cur y is equal to get pos x, get pos y, like get it in one place. Cool, love it. Or actually, we're going to be using based off of this. So let's grab this code. And then we don't need to do the orders stuff here. And we kind of want all this to happen within the for loop this time. Word list 0. And then best is nearest 0 minus px, but we're gonna, yeah, alright, I'll use your language, ChatGPT, just to save myself the trouble. pxpy, that's our position. Start with the first corner, and then check each remaining corner. So for I in range of 1 to length of coord list. Then we do all this horse bucky bull noise. And then we set nearest equal to corners, not corners, to coord list I. If we've found the right one, bestest equals dist, all good. How does you, oh no, nothing moved? I thought, occasionally I see chat move and then I look over and chat didn't move. I don't know what the fuck I saw. Gremlins? So this just takes in a list and finds the nearest one. So populate for first consideration. Say pre-populate, we'll say. Pre-populate nearest best. Check each remaining coordinate in the list. Say it full form. And then we return nearest. Okay, so now we've turned nearest corner into nearest tile, and that means nearest tile no longer needs to actually do the work. We don't need a pxpy. Chat's moving. Jamasian with a bunch of Ronin Pawn logos and chat, or emotes. That's it, right? Emotes? x2, y2 equals x plus width minus 1. Do we need that? Yes, we do. When we populate the corners, when we populate the directions, indeed. And then... yeah. Okay, we just get rid of that. And we get nearest is equal to nearest tile of corners. Okay, so we just pass the corners into our nearest tile function, and we'll get back the nearest one, and then to figure out which direction we should pass, nearest. To figure out which direction we should pass, if I guess we do I equals 0. We need a variable that persists outside of the... No, we don't. Just for I in range of 4, we know because it's corners. If... I mean, I presume I can't just say in, even though we're in Python. That's why I'm doing it this way. Like, I think in this situation, you would be able to say in real Python, you would just be able to say, for I in range of 4, if nearest equals corners I, orders equals directions I. And break. Break is a for loop command that just breaks you out of the for loop. So we're stuck in this loop, we're running it until we hit the range of 4. If we find the one that we want, we don't have to stay in this loop, we're out. We break out of it. So for I in range of 4, if nearest is equal to corners I, orders equals directions I, break, and then hand out the nearest and the orders. That's how we do it in a road down here at Spoil Sport Motors. So there's nearest corners, nearest tile. Yes. I should test if that works before we go any further. Before we go any further, I want my ends. Yeah, I'm just going to interrupt. Paste you in. Start you up. Almost up to 1 million pumpkins. Okay, we got a problem. Error. Yeah, I did an assignment instead of a conditional check. That's apparently a theme of the day. Another error. Dist equals corners I. There's no such thing as corners I in this. It's coord list. Uh-huh. Okay. Try again. Seems like we're getting it. Yep. It's all still working. So that works. We've managed to nest the... We've managed to break out the nearest tile concept and then, you know, re-nest it within nearest corners. Now that we've got a straight-up nearest tile concept, now we can use it in move to try and determine, and let me just copy the running code. Now we can use it to try and determine, like, whether or not we should go to the actual tile, or whether we should go to one of its cousins in another dimension. So first we have to generate the cousins from another dimension. And so, low x and high x are going to be equal to cur x minus In fact, we're going to get the world size once so that we don't have to keep calling that function. World size equals get world size. Again, this would just be good micro-optimization concepts. In this, who knows whether it makes any difference. Low x and high x is equal to cur x minus world size. And then cur x plus world size. And do the same thing for y. Low y, high y, cur y, world size. Okay. So, I'm gonna section this off and I'm gonna say, consider if wrapping the world would be faster. Consider if interdimensional travel would be faster. I like that better. So first we preload the alternate versions here. And then we need to figure out which is like the fastest, which is the best destination, or the best route for where we are. So we just use our nearest tile function, and nearest is equal to nearest tile, and we pass in, it could be, this can be a tuple, right? Yeah, this can be a tuple. So we do low x, cur x. No, we want to create actual coordinate spaces with this, don't we? Alright. Low x, low y has its own coordinates, and then cur x, cur y and then high x, high y. Okay, try and make this a little bit more legible. Like that. And I'm gonna actually change this to coord list. It's fine, I can accept a tuple or a list. It's not like breaking it, it's not writing to it or anything like that. So that would, yeah, that would be fine. So we find the nearest, and actually, we can just immediately, instead of having nearest, we can immediately set this to dest x, dest y, and then it just works. I mean, that's the theory anyway, right? Is that it should just work from there. I might do this. Yeah, I might do that. And I would keep you up here so that you're logically in the same, comment space. Yeah. Like, I don't think there's anything else that needs to be done there. That just changes where we're moving to. My only concern is that when we're moving negatives, because there's some abs code in here. And, but the D's are based on true code there. And then is steep considers it in an absolute sense. Yeah, I'm concerned. about when we try and move on a negative. Because there's... Our D's get absed a lot. Do they get absed all the time? Because then I could just do it. I could do it up front. Like, once we've set our D's, these D's get absed. Looking for D's. These D's get absed. That D gets absed. Yeah, all these D's get absed. So we could just do this. And have the same functioning code, but this is going to be a problem for that. And then we don't have to continuously do an absolute call. And drop the signage from something. That is never signed. But I'm concerned. I'm concerned because we can get negative values. And I feel like that's going to cause a problem. Anyway, let's copy it in and watch everything explode. So this is utilities code. So you go in here. What are you doing? There you go. Alright. Really? It just runs? Here we go. Okay, something already went wrong there. Okay, but wait, stop. Because we, like, got to up here, and then we went to, like, here. Which... I think that's a good sign, because I think it means that we were thinking in terms of going in the correct direction. But we didn't. Probably because of the absolute handling. So let me just see that one more time. I know I'm wasting, like, seeds and stuff, but... Suck on my chocolate salties. Why in God's name would you have done that? And then you didn't actually do a full 6 here, which is... So you moved here. So you started here. And then you should have just gone up and hit this spot and went. Out in here, and you should have just gone to there, because that's the nearest corner. So what I would want to do right now is actually, like, take out our stuff that changes where the destination is. And just make sure that it's not because I changed the abs thing. It shouldn't be, but I just want to affirm that the changing how abs is handled didn't do this. Everything should still be working. Yeah. Beautiful. Yeah. Okay. That all still goes. So except for the fact that it's commented out, this is the code. Corrects minus world size, corrects plus world size. So it should be like, you know, if it's 0, 0, then low x should be negative something, and da-da-da-da-da. I think the abs is a problem. So let's just consider what it is without absolute. Okay. Is steep. Our current y will never be negative, just so we're clear. But our destination x can now be in the negatives. What if we solve this problem by not changing the destination x, but by changing our current x? By altering what we think of as our current x and current y. Because then we can keep it in a positive integer space. We don't ever have to deal with the negative nonsense. If we change our current x to be like, we get the nearest tile back. What do we get? Near x, near y. No, wait. So we change that, but what we pass... fucking balls. My idea is that our space on the grid becomes the low x. Okay? And then we propose a mid-x and a higher x? We're just changing the relation. We're saying if we're at 6, add 12 to it, we're at 18 instead. For the sake of comparison. So we get back a potentially negative value from nearest tile. And then we take our current position value, our x and our y. It's just, you know what the problem is? It's been 5 hours. It's been 5 hours, but I can almost see how I do this without having to break us out of the positive integer space, and it's a brilliant shortcut that doesn't require me to, like, rebuild and reconsider everything. Let me just look here. If we took all the absolutes out, where do the d's get used? In considering steepness, why does it matter? The d's are supposed to be the distance between the current x and the end x, which should be the same, but what if we get a negative value? If we've got a negative value as our destination x, then it turns into like -3 minus 3, and that becomes -6, and that is the distance, and so the distance is fine. Yeah, that's still the correct distance.
Let's drink until our hearts stop.
I just did, but I will have some more. Hydrate, and maybe the brain will work a little bit better. But the distance is the same, even if we've gone negative, right? The distance between, you know, a -6, and if we're at 0, and we find out that -6 is where we want to go, then -6 minus 0 is at, you know, -6 minus 6. We'll never get a negative number for a second number. So the distance does remain the distance, and so is steep is still a valid consideration. Where else do we use the D's? Down here, in range D's, so for the range, we need that to be an absolute. Yeah, and it would be the number of times we move, sure. Error plus equals D's. So when we add or subtract to it, this is the place where it could be a problem. This is the place where it could be a problem. But I don't think it is. I don't think it is. I don't think that that's the problem that we have right here. Yeah. I think it's going to be something else. I don't think it is the negatives. Now that I've considered it. So let's interrupt. Let's put this back online, and let's throw in some prints and figure out what the hell's going on here. So, quick print. What I want to say is if...
In 3, 2, 1, fire!
if it's been changed is really what I want to know, but then I would have to keep it... you know what? It doesn't matter. If, just print. Print low x, low y. Actually, just print this shit. Give me this. When I hit end, why do you go to the top again? It's a hell of a fake IDE you've made. Not the end of the line you're on, surely. That's not what you wanted. Okay. It is a toy. I have to remember that. It's a toy, it's a game. How much are you going to ask of it? So I want to print all those. And I want to print dest x, dest y, and then like that. Okay? And go ahead. I was going to quick print, wasn't I? It is fine. Up here is where your print statements will be. Ones that you'll be able to actually read. What are you planting? Okay, trees. Alright, so that's like one loop and a little bit more. I wanted to give it one whole loop so that then we can look back at it. So, 0, 0, and then we determined that 0, 0 was the, you know, fastest place to get to from 0, 0. Good call. We landed at 0, 0. 0, 6, we found 05 to be the number. Why do we find 05 to be the number? And then we landed at 05. And then out of the options, which were -12, -2, 010, or 1222, how do we get those numbers? Those numbers just don't match. That's our cur X, cur Y. I did this upside down, that's why. Am I crazy or am I right? I mean, in either case, you're crazy because you're the one who did it. But I just set us up to be comparing the nearest tile from our position to our position. I'm supposed to be doing this with the destinations, right? Consider if interdimensional travel would be faster to get to the place that we're going, not our current X minus world size. It's our dest X.
You can't trust the system.
I am the system.
Man.
I'm the faulty machinery here. And it's definitely been 5 hours. Is this 5.5? 5.5 hours. With only one live stream break, by the way. As a matter of fact, I'd probably benefit by just turning this off entirely with my light sensitivity at this point. But yeah, this is supposed to be nearest tile of the low X and the high X. I should be passing the dest X and the dest Y. And then this should be against the destination X. We're supposed to be seeing if the destination in an alternate reality is closer to determine whether or not we can travel around Pac-Man style. Let's see about that. Hey, you got numbers the first time. That's interesting. Okay. You found the correct place to start this time. That's encouraging. Here we go. No, you walked all the way back. You were supposed to, like, figure out that it's better to go around the world to get there. This would be another place where it would be better to go around the world to get there. Okay. Streams like this explain why Windows OS is now several gigabytes. What? What do you mean? How? What? What do you mean? The code gets, I don't understand. Explain. Code gets more unseemly as the programmer becomes overworked? Is that the... I don't get it. Let's look at our numbers. Let's stop this, because my brain is, you know, only has so much capacity at this point in the day. So, what I'd like to be printing, I think, is the current, like, where we are currently. Cur X, cur Y. Code gets bigger and bigger over time. Just that we get more and more complex. Alright, run it again. I want to see where we are. You know. And the decisions that we're making. It's right here. So I'm going to stop that, because that made the wrong choice. So, we were at 011, and we had the option from 011. What? Are you still... did I program in the wrong place? And then just not move it over? No. What? Zero 11 is supposed to be our current position. Right. And then low X... Oh, I'm printing the wrong shit because of what I was doing before. Because I had it backwards the whole time from the start. Alright, one more time round, and we'll stop it at the same place. Yes, yes. Go, little drone, go. And I guess when we solve this one, that'll be the end of the live stream, huh? Okay, now this is the wrong decision, so we stop. So... we were at 011, and we wanted to get to 6.2. From 011, we could have gotten to... we're saying 6.2 also exists at 1814. Oh. So the problem... we're not wrong now. The problem is the corners thing that we're doing. Because we are closer to 6.2. Is that right? I'm pulling up a calculator. Because 11 and 14 are only 3 apart from each other. Whereas 11 and 2 are 8. 0 to 6 is 6. Whereas 0 to 18 is 18. Okay, so there's your problem. Is that we wanted to get to 6.2. 11 and 14 are very close, but 0 and 18 are very far. But we should have been looking at 0.14. Right? Wait. Shit. We should have been looking at 6.14? 6.14. We got -6, we got 6 and 18... I think what I've been doing is I've only been considering the dimensions that exist, like, if we're thinking about this corner, right here, then I've only been, this tile, I've only been considering the dimension that exists down here, and that exists up there. But I haven't been considering this dimension, and this dimension, and this dimension, and this, wait. You're there. So this... there you... shit. Breaking my own brain here. If you're there, then you exist there. And you exist there. But, yeah. And then the other ones are way the fuck away. So... whoa. But... I need more tile considerations. I need low X, low Y. I need dest X, low Y. I need low X, dest X. Alright. I need a bathroom break. Yeah. This live stream will be ending when we solve this, but I need a break. I've got a very good idea of what needs to happen now, and I think we write another function that gives us all of the dimensions that exist around us in an 8-box. A very common concept in like hitboxing and old school gaming and stuff like that is to, you know, test right, left, up, down, but also down, left, down, right, all that kind of stuff. So yeah, we need to be passing into our utility function that checks for tiles, whatever the fuck the name of it is, nearest tile. We need to be passing all of those 8 nearby dimensions. Right now we're just passing 2 of them, and they're at a hard diagonal to the world. We're not thinking about this dimension, and this dimension, and this dimension, and this dimension, this dimension, this dimension. So we write another function that we pass into just our current, like, just the destination X and Y, and it generates all of the possible permutations, puts them into a list, and then we shove that into our function. And that will get us a consideration for all of the nearby dimensions, and that should get us Pac-Man functionality. But I need to pee. And we could all use a break. And so that's what's going to happen. It's a break and a pee. I'm going to turn that down. I'm going to go to the graphics. I'm going to put us into windowed so that I can minimize. And we're going to go to a live stream break. 7 minutes. When we come back, we will solve this thing once and for all. And damn, addictive. Addictive, isn't it? Meet me back here. Don't go anywhere. Pawn not out.
I'm impressed when that gorilla beats his chest for the bits. I confess, I admit, I'm impressed when the torpedo in the vest barks his orders. I'm impressed, and I find that my head's nodding yes, though my legs are not following. I'm inspired by events to remember the exits in back of me. I'm impressed when that gorilla bounds his desk for the bits. I confess, I admit, I'm impressed. To Generalissimo's request, I can't help but feel impressed. On the one hand, he'll give you 5 good reasons to follow him. On the other hand, you see nobody leaving the stadium. I'm impressed by that Godzilla's flaming breath for the bits. I confess, I admit, I'm impressed when the tornado from the west crushes buildings. I'm impressed, and I find that my head's nodding yes, though my legs are not following. I'm inspired by events to remember the exits in back of me. I'm impressed when that gorilla beats his chest for the bits. I confess, I admit, I'm impressed when the torpedo in the vest barks his orders. I'm impressed.
Bullets, 2 in the clip, however many on the floor. Blood pools up and the emblem of the faith is covered. Blood then touches the desperate cracking ground and the earth slurps it up. This liquid like precious crude. Christ the king of punk rock town tonight because Christ found the fire. I won't go to hell for you anymore, so say hello. Pulls back the hammer. Opium and oil dried up years ago. Christ, oh Christ, cracked open the cement tomb tonight. Let the communion begin. Burn this oil, it is my body. Shoot up this dope, it is my blood. It was never black helicopters and UFOs. It was worse. It was CNN. It was ABC. What do you guys think of the rant I just did instead of the lyrics I've been using?
Life is a fleeting bullshit, arbitrary waste of my time. I can't imagine more useless ways to spend the universe's dime. And if I had it all to do again, I'd pass, but hey, thanks, 'cause I know you're concerned about me when you should worry about the chronic disease. It's gonna creep up and squeeze the fucking life from your knees when you've just hit your 30s. This sucks, and I am booking the last flight to hell. Fuck all! It's gotta be better than this, comparatively swell. And if we die, who cares when you're trapped in a body that makes you consider pros and cons of doing laundry or clean and cat litter, 'cause the washer and box are in the basement and the basement is 10 miles away, aka 2 flights of stairs.
Hello, I am the Ronan Paul, and welcome back to a twitch.tv/Ronan Paul live stream on twitch.tv/Ronan Paul. That was an original song that I would like to produce someday. I figured it out pretty nicely. That's exactly what I wanted from it. So, we are playing The Farmer Was Replaced today, and we're on coming up on hour 6, so my brain isn't quite working. This is why, you get a lunch break in the middle of the day, and it's also why, really, most work days should be about 5-6 hours long. Like, especially for intellectual work. You're not getting, what you're getting at the end of that day is not worth much. For the people who, are experienced enough to be, old and not have the the energy to burn, not be able to sacrifice their bodies on the crucible of your fucking corporate goddamn bullshit tits. Anyway, so yeah, we're trying to figure out, these are all the ways that my brain isn't working. I can't even, click in to doing the live stream. So what we're trying to do at this point is make our little guy here aware of, there's also a little bug that we've got that I'm not addressing right now when we pop that pumpkin. But we want to make our guy aware of the ability to travel multi-dimensionally, to wrap around Pac-Man style. If you keep going left, you end up on the right. If you go right, you end up on the left. That's how this game works. Right now, my code only, it works on a grid. And it works incredibly cleverly on a grid, by the way. We're using, I can't even remember the name of it anymore. Bresenham's rasterized linear algorithm. Jack E. Bresenham from 1962 came up with that algorithm. We're using that for movement here. Just to be, fun. Just have with the cleverness and stuff. we want to introduce the idea of being able to travel off the grid to show up on the other side of the grid. And the easiest way that I can come up with to do that is to introduce alternate dimensions. So just presenting the idea that all of this exists also over here, and 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 there, and there, and there. And so that will allow you to determine which dimension is the closest, closest one to go to reach the place that you want to be. And so what we're going to need for that is one more. I'm just going to grab the code from there, make sure that what I've got is the same as what we're working on. We're going to need one more little function here. And the function is going to, I'm going to call it get dimensions. And what we're going to pass into this function, zoom in a little bit, what we're going to pass into this function is, we just need a coordinate for our x and y, for an x and y anyway. So, yeah, just give me an x and y. In fact, we'll call it local x and y because it exists in the local dimension. And so, what we want now is a min x and a max x. Is that right? I think so. And they are going to be local x. We're going to do the thing that I did before, which is we're going to have the world size. We're going to get it. Get world size. Min x max x equals local x minus the world size. And local x plus the world size. I'm thinking maybe I want to pack this into a data structure instead. Like, what if it were, x's? X's. Equals local x minus, and then local x and local x plus. And then the y's, because we're just so cool, are local z minus world size, and then local z plus world size. Okay. And we pack those into a tuple for high-speed access. And then we say dimensions, and it's a list. Dimensions. Thank you. Dimensions, and then we do 4. Should have already called it x instead. No, I haven't. So 4x in x's. In fact, the way that you would usually do this is 4y in y's, and then 4x in x's. We want to create, like, all the combinations that we can of this that aren't local x, local y. Local z? Who's local z? Local y. Local y. Local y. Shout out them typos if you see them. So, we want to loop through all of them. We want to create every single possibility that we can get. So, dimensions is equal to, or no, dimensions append. And what we want to append to dimensions is xy. For x and xz, and each one's going to be an integer value. So yeah. Yeah. So we just create a list of dimensions, so what we should end up with is we get like the minimum x. So I'm going to do this toward the camera and for the camera. Get enough light to make it worth, you know, doing any sort of miming here. Ah, damn it, I went all the way around. We'll go with green then. So we're going to get minimum x, right? Minimum x, minimum y, and then local x, minimum y, max x, minimum y. And we're going to get minimum x, local y, max x, local y, and finally minimum x, max y, local x, max y, max x, max y. So we'll get all 9 of the possible dimensions returned to us from just the one, and it'll be a list of these tuples, which we can then hand into our nearest tile function, which accepts a list of tuples. And then it will tell us which of those destinations is the nearest one to get to. That's the concept here. So I think that just does it. I don't think it's any more complicated than that. Which means now I don't have to have all this code in here. We consider if interdimensional travel would be faster by saying get dimensions of the destination X, destination Y. So what is equal to that? It would be then we pass it into nearest tile. So the returns of that go into nearest tile. And then what nearest tile gives us back is an XY tuple. It would be so, that's why it's so nice when you can use, like, the typing hints and stuff in Python, so that you don't have to, like, what does it return again? Nearest tile, so what we get back out of that should be our new destination X, destination Y. So we're taking in a destination X and destination Y, and then we're checking to see if it's faster to go to an alternate dimension to get to that destination X, destination Y. If it is, then we set it to, and then we go there. That's the idea. Let's see if it works. Let's rather find out how many bugs were. Oh, I left a giant pumpkin in fucking circulation. Here. Alright. First error. Loyal Y, Loval Y, in fact. So typo. Well, here. Second one. Append takes 2 arguments. Append, this is supposed to be a tuple. So we're supposed to be appending that in that form. See, we're packing the X and Y into the tuple, and we're appending that single tuple to the list. That's what I meant to do. And you cannot index into none. So nearest tile coord list. Did we not return from get dimensions? I didn't add a return statement to get dimensions. Return dimensions. There we go. See, we weren't handing anything back out of here, so when we called it up here, nearest tile was just receiving nothing because there was no return from get dimensions. Now there's a return. Let you kick it out, and we have started moving. Let's see what happens. It did it. Except it found the wrong corner, but it worked. watch here. It should go around the world. It didn't go around the world, but that should have been the closest corner.
Impressive.
So, it's semi-working. Our problem is now that it's not being considered for the sake of, like, corner detection. Which is a lot of numbers for it to consider, but, I mean, this is what computers are good at. We can have corner detection be multidimensional as well, in theory. But it is using it, you know, to get from here to here instantaneous, or actually from here to here, instead of going this way, it goes the other way. This one, however, like when it gets to the end of this, it's seeing that this corner is the closest corner, and so the fastest way to get there is to just come down like that. It's not finding this corner. It's the only reason why we... And in that case, it was just correct to do it that way. It's very interesting, all of the ways that it's like different paths that it's finding in order to complete the same circuit. Having a partial awareness of interdimensionality. That's neat. That's really neat. All right, let's see if we can't get it working to go ahead and copy the live code. Still running, right? I'm just being quiet for a second. Let's see if we can't get the nearest corner system dimensionally aware. So nearest tile, we're just passing corners right now. What we would want to do at this point is actually create a very long list where we get... Because we're going to get 9 total dimensions for each corner. So it is just 9 times 4, so it's 36 different potential tiles as which one could be the nearest. I love it, though. Shouldn't be too hard to squeeze that in, either. For I in range of 4... How do I get them all in here? I've made move to dimensionally aware. But what if I just made nearest tile dimensionally aware implicitly? Any coordinate you pass to nearest tile, it automatically considers, you know, all 9 of its potential dimensions. Are any new upgrades available? Oh, surely. Many, many. But I don't want to. I don't want to get... want to unlock more stuff while I'm still messing around with my incredibly unnecessarily convoluted movement system. Nearest tile should be the thing that's dimensionally aware. Interdimensionally aware. So we can use get dimensions, then we don't have to fuck around with that here just by calling nearest tile. It would find it. So nearest tile accepts a coordinate list. For every coordinate that you pass it, it finds all the dimensions of that coordinate and tests them all. That's my idea. There's another list operation that wasn't mentioned. Curious if it exists here. Coord list.extend. Oh, Do you know extend? It doesn't seem to know extend, and when I did that, it only suggested append, remove, pop, and insert. So extend allows you to, like, tack one list onto the end of another list. And we're gonna have to do that manually, I think, in this game. For which we could write a little method that does it. So how would you do that? Because that's what utilities are for. So let's do list extend. And then list 1, list 2. So how would you take a full list and attach it to the end of the other one? I guess you'd just do for I in range of length of list 2, which I could test, but I assume that we can't just do in this game for I in list 2, which is how in Python you can actually do that. You don't have to put everything into a range and access it by an index if it's an iterable object, meaning it has, you know, multiple things inside of it. If it can be itered, then you can just say for I in list 2, and actually you wouldn't say for I in list 2 because I usually represents a, you know, an integer for how you're iterating through it. You would say for, you know, whatever's in the list. For the object, which would be a bad thing to use. But I'll just use for L in list 2, which is also a bad character to use because it looks so much like I and 1 and everything else, so don't do that. For E in list 2, list 1 dot append E. There's list extend. If that works. If it doesn't work, then we'll do the range thing. But that gives us the ability to do an append, which means now in the nearest tile function, new coords we want to do for coord in coord list. It's not complaining yet, so I'm gonna assume that I'm allowed to do this, even though I had assumed that we couldn't before. For coord in coord list, usually you'd have to do this to make a genuine copy of the original list. We don't want a genuine copy of the original list. We want it like this because it's going to be included in the return from get dimensions. So for coord in coords list, new coords, or actually we would do extend list new coords with the return of get dimensions for the coord in question. Consider if travel to alternate dimensions is faster, is nearer. If, yeah. If a tile in an alternate dimension is nearer. If consider if the tiles analog in an alternate. I just love the idea of like the alternate dimension language. There are multiple versions of everyone. Tiles analog in an alternate dimension is nearer. So new coords, for coord and coord list, extend list, new coords, get dimension, and then for the sake of not having to work so hard, I'm going to change the coord list to be equal to new coords. Yeah. So that all this code just continues to run as it ran before. That's a lot of stuff. What? Expected a comma or a closing bracket? Sorry? Ah, here is where you expected. Okay, let's chuck it in here, and I just assume this isn't going to work. Oh, pop your big pumpkin, then. Pop your big pumpkin. I'm waiting. I'll wait for you. You got 2? Come the fuck on. He went to the wrong place to scan. I finally understand what's happening here, I think. He scanned the wrong location. Interesting. This just might fix it. There we go. Do you need a second close bracket on the extend list line? I don't know Python, but I assumed that was required. On the extend list line. List extend, list out append, not that one. Extend list, open bracket, close, close, close. Oh, you were just, that was, you noticed that. I see, and I found it. Okay. Actually, if this works, then we don't need to consider interdimensional transport by doing it ourselves. We just get nearest tile. Of dest x, dest y. And that implies the get dimensionality. Yeah. Yeah, I expect many errors before we get this up and running again. Extend list has never been defined. Ah, it's list extend. Where you at, Don? Oh, good, the error disappeared, so now I have to just hunt for it. Loving this shit. Extend list, there we go. List extend. Error 1. Error 2. Get dimensions takes 2 arguments. Ah, I just threw in a coord. Can I do this? So the star, no, okay, it's not. In true Python, the asterisk before a variable that's a tuple, or that's an iterable, actually explodes the contents of the iterable into the space. So you would say star coord here, and it would automatically explode it into what I'm now going to have to type, which is coord 0, coord. Actually, no. The better way to do this, if it supports it again, is CXCY. You can explode, you can populate multiple coordinates in a for statement like that. So let's see if it supports this. Like, we're getting into the place where it's like we're at the edge of what I would expect the game to support, and I think we're beyond it right now. If it supports this, it's doing some extra. Okay, error 3. Nearest tile takes 1 arguments. Right? You want to tell me, like, who called it? Okay. Might have a little bit of a inconsistency there. the left-hand side of the assignment didn't match the right-hand side. This is where I'm saying I don't think that it would be able to do this. What do you mean? The left-hand side of the assignment didn't match the right-hand side. Coord list. Oh, I'm sorry. Yes, no. Coord, for coord and coord list, so this does have to be like this. Where we could usually, so to go back to what I was saying before, where we could usually explode it like this, what this explosion would do if the program supported it, is it would do this. Coord 0, coord 1. For everything that happened to be inside of it, however much. Okay, 4. You cannot index into 0. Huh? Nearest tile accepts a coordinate list. And then from the coordinate list should be a list of tuples. So the tuple should be 2-packed in it. So we grab the tuple. The tuple is now called coord. And then I think maybe you just can't do this in here. Itters would be a very complicated thing to support. I'm going to assume that itters just don't exist here. So let's go back to the idea of for I in range of length of coord list. Could be something that I'm doing wrong and the game actually does support it. Maybe it doesn't. I don't know. But this will definitely reduce this down to something that should work. So list extend, new coords, get dimensions. Get dimensions takes a local XY, and maybe it should. Maybe are we packing it all up into coords, or aren't we? I don't know. I'm leaving it as it is. Into tuples, I mean. Are we packing it all up into tuples? So get dimensions does take a 1 and a 2. What I need is coord I 0, coord I 1. And so the list of tuples, the I gets us into the tuple, and then the 0 and the 1 address the tuple directly. And then assuming that this doesn't work anymore, I would also change this. For I in length of, in range of length of list 2, list I dot append, list 2 I. Yeah, I think so. Alright, how many more errors now? Surely. Coord has never been defined. You must assign a value to a variable before using it. Ah, yes. I haven't, have I? So this is supposed to be coord list. And coord list. I could also pop it out. In fact, that's probably more legible. So if instead I said coord equals coord list I, this is a cleaner way of expressing it. And then I can do what I was doing before, which is coord, and then I just take off the I, because we've already accessed the tuple. And more error. A square bracket close is expected here. Ah. Thank you. Cannot index into 0. Same issue we were having before, so maybe it does support the other way of doing it. Well, live and learn. I haven't learned, though. I'm not entirely sure. So then something is passing in the wrong kind of data to nearest tile. And here we have nearest tile, and we're passing in It's supposed to be a coordinate list. So it should be like this. It's a list containing coordinates. It just so happens to only be one coordinate. It's a little bit weird. Oh, Jesus, I didn't expect it to come on. So I don't expect it to work now. We've gotten the syntax bugs out of the way. Did you see how long it paused to try and figure out where to go next? Is he gonna do that every time? Okay, here we go. Tried to read the variable orders before a value was assigned to it. That means that none of them matched. That's not so much of a problem here. It means that orders was never assigned, which it should always be assigned because there should always be a match to what we find out of the nearest corner. No. Now there won't be a match necessarily. Because we're traveling to an alternate dimension. Shit. So now we can get a number back that is actually in an alternate dimension and can't be directly compared to corners. In order to determine what directions we should be passing. Fuck, that breaks, like, the whole concept here. Yeah, that's a hard one to address. We could pass back which original coordinate the final coordinate was derived from, you know, because we're looking at it in a different dimension. But what we could have is, let me just go ahead and copy all the changes that we got that made it almost start to run. Back over here. Nearest tile. It's accepting a list of coordinates. And then it's finding whichever one happens to be closest. But if we could keep an association of like which one it is, then we could return nearest and the coordinate. Like the eye, ostensibly. The original eye. Right now, we're just doing chord equals chord list extend, new chords, get dimensions, chord 0, chord 1. So we're extending the list, and it's arbitrary by the time we look at it. We extend the list separately. We get this list back from get dimensions. Here's a way to do it. Way. I'm going to say list length is equal to length of chord list. Which, by the way, now I can use that here instead of having to call it again. Again, my goal was to do this in like a really fun and wild way, not to do it in the most efficient way. We might have written a thing because it has to consider 36 other coordinates before it does it, that it's going to just like chug within this game that's trying to simulate Python, which would handle this like nothing. This kind of, you know, arithmetic CPU operations wouldn't be noticed at all. But so list length of chord list, now I can use that here, but the idea would be by the time we get to the end of this, we will have extended the list in order of how it came in, and whatever the I is of the index of the final one, we can divide that against, and we can figure out like which universe which package it was originally in. That's my idea here. So if the dist is less than the best dist, then it becomes the new thing, and then we get the nearest is the chord list, the best dist is equal to the dist. But I want the best I equals I, so that when we're done here, we can return nearest, and then how do I get this exactly? It's going to be something like, we've got the list length, so let's say it's, 50 something. Let's say it's 50. No, there's always 9 boxes. So let's say we've got 36, because it's usually 4, right? So 36 is the list length, and then we divide by the I? No. The I is where it happened to be. The list length would be 4 then. The length of chord list at the end will actually be the incredibly long number. So 36, and then if we divide that by 9s, because it should always have been considered in a grouping of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. We divide that by 9. Times I. No, I will have been from in the middle of it. El Gavo sent 10 New Zealand monies on the PayPal. Thank you, El Gavo. I will spend your, I don't know, your Lord of the Ring bucks. What do you, your Auckland dollars? How do I get from the I? Like, the I represents something. It represents, like, its position within a certain matrix, and if the I is 12, then that means it came out of the second one in the list. The second number. Hobbit feet hair now, I think. Okay. But how do I get 12 back to being 2? Or back to being 1, really. So the length of the coordinate list, it's 36. We got 12. If we divide 36 by 12, we're not going to get it. It's 36. Is it mod? 36. I've got my calculator open now, just trying to get a sense of this. It's not mod. 36 divided by 9, it's the 12. How do I get this out of here? Basically, what I want to say is if it's between 0 and 8, because those are the first 9, then the number we want is 1. If it's between 9 and 17, then the number we want is 2. No. If it's between 0 and 8, we want the number 0. If it's between 9 and 17, we want the number 1. That's what we want. And it's not a complicated piece of algebra, but we've been here for 6.5 hours. So, how do I get it? "36 is the length, but it'll be like an actual reality of 0 to 35. And then let's say I equals 12. So we want to return, return 1. It's the second value, which should be stated as 1. Long boy stream. I'm a long boy. So, in fact, what I'd like to say is that values between 0 to 8, fuck off, 0 to 8 are equal to 0, 9 to 17 is equal to 1, 18 to 26 equals 2, and 27 to 34, 27, 8, 9, 31, 2, 3, 4, 35 to 35. I thought there was something wrong with that. 35 equals 3. So, how do we express that? How do we get 12 to land as 1? "12 divided by 9 is 1.3. You know, it's floored. That's how we do it. That's how we do it. So then, 18 divided by 9 is 2. 27 is 3. So it's just floored division. I mean, you're all in chat too. But it's just floored division. So what we want is the length of coordinate list floored against I. And that will return the actual number of the item that came in. And that means that this is a silly thing to do up here. We'll only be using this value once, right there. And then we will be using it down here multiple times. So, in theory, I could save myself a trip by saying list length equals length of chord list right here. Which, again, this is called micro-optimizations. And you probably shouldn't waste your time with them. Is what people argue, and they're wrong. You listen to me. List length divided by I. And so now, what nearest tile returns is the actual tile that you want to go to and what dimension or what original tile it linked to in the list. I could actually pass that back if we rewrote this a little bit. I could pass you back the actual original tile, and then you could just compare against that. So if I didn't overwrite the original chords list, That would be so much, like, clearer, I feel like. Yeah. So if we just use new coords from here on out, so give me you, anywhere that says coord list, new coords. If it were easier to, like, rename things, and maybe it has a rename function, I would change new coords to something like, you know, interdimensional coords. Hmm. 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 And then list length of new coords, that still works. Okay. And so now what I can do is actually pass back from the coord list the actual item from which we found that in another universe it's the right number. Ah, all right. So now nearest tile now passes those back. So wherever nearest tile gets used, no, I double-clicked it. I really fucking did, though. No. I'm looking for nearest tile in the file that I'm in. Here we go. Nearest tile. We need to capture that and use it. Or not. So now I have to actually break it out. It's going to be dest, and I don't think we need it here. So dest x, dest y equals dest. So that should still function like that, but it was somewhere else where we use nearest tile. It's in nearest corner. And then match. And so if match equals corners I, then orders equals directions I, and that's the problem that we were trying to solve, was that we weren't setting orders before. Okay. Problems. Oh, I put that on the wrong side. We want nearest and match is to collect what nearest tile returns. And go. Yeah, I didn't think so. The index 1 was outside the bounds of the list. Huh? Ah, okay. No, you're probably right that this needs to be subtracted by 1. So if the list length is 1, and we get 1 back, then it's going to divide to be 1. That might be a problem. That might be a problem for us. Here we go. First use, right now. Alright. It certainly had to work for it. Right now. It did not find the right moment. It did find the correct moment here. And some crazy shit. My code is definitely making it like chug and think about where do I go next, which is, I like that. I don't know exactly what's going on there. I'm gonna stop it. As a matter of fact, I'm going to run it again from scratch so I don't have to look at a complicated, you know, big mess of shit. And just stop it when it goes wrong so that I can see, can tell what the print log says, because, like I say, we're coming up on hour 7. It's 6.5 hours at this point, and we need this to wrap up. Here we go. And stop. Yeah, you went to the wrong place. -1, 12. So we landed at 11-0. Alright. We were headed to -1, 12. Where were we at that point? Wait. You start down here and you went and then you're saying from here you were gonna go -1, 12. Should have put you there. Let me see what happens again. There are far easier ways to make it Pac-Man aware, but this is my fun way. It went... it was there for a second. -1, 12. Because you're here. So if you go up and over 1, then you should be here, and that's the nearest corner. And you're correct. And then from here, you needed to be going west. So it found the right place, and it went the right place. It just got the wrong directions when it got there. It was supposed to be going west, but see, it went east instead of west. See, it got east-north, but -1, 12 should have been west-north, and I think that's going to come back to, like, this issue. That I was like, that could be a problem when I had to take a 1 off of this. Because when I do the math on this, and I say, if, did I leave that stuff in there, that comment? Doesn't look like I did. When I say, if the number was 12, right? The list length was 36. And we divide, we floor by 12. If the list length was 36, we floor against 12. Am I crazy? Why did I think that floored division was the way? I was doing the math correctly for a minute, and I think it's been such a fucking long day that when I got the right math, I don't know. My brain short-circuited for a second. Oh wait, I've got the old calculator still? Close this one down. What was the calculator? What did I do? It's dividing against 9. It's division against 9. That's what I was trying to do. And I did list length instead, but it's just supposed to be against 9, so it's actually I divided by 9. It's not list length. And in that instance, we shouldn't need... We shouldn't need list length at all. We just do length of new coords. It's division by it's floored division against 9, because then 12 floored against 9 equals 1 point something, which is 1, and it gives us the right number. But 8 against 9 is below 1, so it returns as 0. We get to correct the location. Okay? Maybe. No. Shit. It might just be that it's so powerful because it now understands Pac-Man. Now understands its Pac potential. It's completely lost now. The importer module does not have a syntax error. Shut up. So, we're getting the correct coordinate for 0, 0, but we're getting west-south. Let's see if we get the correct coords. 0, 6 is correct, but we got west-south again. So it's like mixing up which of the values it's actually assigned to. -1, 0 was the closest. And then 6, 15. So at a certain point, it's like that. I don't know. We're in different dimensions with our prints. Where are these prints, by the way? Print. Do you see it? Like, is this supposed to be helpful? What am I... Where? Highlight it. It doesn't highlight? Alright, well, here's quick print. So that tells us where you landed at. That's brilliant. I don't mind that. I ain't hating that. So 0, 0, 0, 6 landed at 11, 0. Is that right? See, we're getting the corners now, so I don't know. Where are the other prints? Doesn't highlight, apparently, so I don't even know which one I'm supposed to be looking at. Here, quick print. Landed at, right. Next. Not that one. Quick print, here we go. Those are the move directions that you receive. That's fair enough. I think what I want to do... Here's tile. Not you. Not you. print match. Quick print. Okay. Start it back up. They're all matching west-south uniformly, which is weird. But they're also returning 5-5. Like, we were on 0-0. One of the options was 0-0. Should have been 0-0. So is it just returning the wrong guy? Like... I didn't. Oh, that's where it was. Okay. But it went away because I Control-Z'd. Alright. I need nearest tile to be the one reporting. And I want you to print I. And print the original chord list that you received. Quick print, quick print, quick print. Okay, and now this will tell us something. Is this? These numbers are right. I is 35. Why would I be 35? And why would it return 5-5? 0-0 was one of the options. Surely 0-0 is nearer to 0-0 than 5-5 is. Give me 9. This is what I honestly meant. But so, you're returning... You're finding the wrong shit, is what I would say here. But no, you're not. You're returning the nearest. You're recording the wrong I? No, you are finding the wrong shit now. How are you finding the wrong shit now? This was just working and we didn't change. I didn't think we changed a part of it that would make it not work in that way. Yeah, no, the nearest that we are returning is the correct nearest. 0-0. And 0-6. So we're returning the correct location. But it's being matched with bullshit. West-south is not 0-0. And it's because the I that we're passing back is wrong. How is that possible? Like, this is where we set nearest, and we set it equal to new coords I. And so, if we end up with 0, 0 out of here, out of nearest, if that's what we're handing back, and it is, that's what fucking prints up here, bring it down so that we're, you know, not feeling insane. What we're printing is I, it's the floor of I divided by 9, and then we're printing the nearest, and the nearest is 0, 0, and 0, 0 is, like, the fucking coord. Alright. 0, 0 is the first coordinate space that we had come in. Right. So how does I end up being 3? You goddamn idiot. And all you people in chat are bigger idiots, because you're sitting here watching me, and your brains shouldn't be as baked as mine are. Mine is. It's because we're using I instead of best I. So we're always getting back the final I. I was setting best I equal to I in order to store the correct I. But then I was just using I, which, you know, is declared here and goes all the way through the range and ends up 35 every single time, and so we get the wrong thing back. Again, not a conceptual problem, an execution problem, because we've been here for almost 7 hours. Okay, we're about to see if it conceives of Pac-Man travel. It sure does. It sure looks like it does anyway. We got the travel from that corner to this corner. We can also see it stuttering to try and pick out the correct place to go. Wow. It works. 6 hours to get a system of transit that understands multi-dimensional travel and uses an algorithm that we're not even using anymore because our multi-dimensional stuff is smarter. Smart enough. Still learning how to ingest spaghetti? It is a trick it's something we all have to eventually wrestle with. Alright, now let's see about this little bug where we harvest but we don't replant on the pumpkins. When we get to this pumpkin, what's gonna happen? Maybe it got fixed by us fixing, changing our code. It didn't. It's checking in the wrong direction there. That's what's happening. When we do that, it gets the wrong direction. But only when we do that. Okay. That problem might not so much exist in this code as it exists in this code. Because what I'm thinking is the plant area, it does a harvest and then it plants area and it says use this start X and use this start Y. And then it should come in here. If it's already on the tile, and you tell it to move to that tile, Why would it be getting the wrong direction? The last little bug. If we can crush it before the end of this, I'll be a happy boy. Especially if we can crush it before minute 7. I need less light. It's a little bit gentler. Why would it be getting the wrong direction? Let's put this back up here. And I'm waiting for a big pumpkin so that we can get the data, the quick print output. So we've got a big one. And I'm going to pause it. Right there. I'm pausing right there. We need the latest, which is here. And so I think this is the problem. We were at 11:11. Like, look at all this. We were at 11:11. Is that correct? And we were saying potentially, like, go to 11:11. No? Where were we? We were at 11:06? God damn it, I didn't see physically where we were, and I'm not sure how to read the code here. I'm gonna watch this time when we harvest this big pumpkin. Fuck! Been a long day. Waiting for my crop to get to the point so I don't have to think about it. I'm trying to minimize how much brain power this requires. Plant that fucker. Good. I'll be ready to pause again. This time I really gotta see, like, where it is. In fact, I might just pause here and then step. We're at 12:12. And we just got 0:12:12. I don't know what's printing that is the problem. Down here, there was a quick print. I don't know. I'm going to carry on. I want to see. So he moves here, and then he moves up one. And he ends up here. So going to 12:12 got him to 0:0. And then we said east and north, so go east and north, but... Oh yeah, no, he's going to, because it's this works. This one actually works, so... And then... No! Okay, he started here. So he went, He was on 0:5. And then he asked, how do I get to 0:5? And we said, you're there, brah. 0:5 and move east and south, and that is correct. You're at 0:5. In order to do this, you're supposed to move east and south. He moves east. And it looks like he's moving south. Is this one gonna fucking work? This one goddamn worked. That doesn't help me. I'm trying to figure out a bug. That one actually fucking worked. Well, we got another big pumpkin here to pop, so... I'll let you scan it. Okay, he's getting close. He's getting near the end. So now he's at 11:11. He decides to pop it. Doing a lot of work here, actually, to try and determine what needs to happen, so this could take a while. It's the list append is really where the time comes from. Number of cycles that go in here. If we had a list extension, it would be better. Fuck. Where is it? Okay, it's processing the chords is actually a problem too, huh? I'll tell you what I'm gonna do is I'm gonna let you run until you get there. Thank you. Take that out. Did you print something? Not yet. Now you've printed it. Okay. You're at 11:11. And you said, basically, how do I get to 11:11? And we found that 11:11 is the correct number, and we're passing back a 2. There we go. And so 11:11, east and south. We needed west and south. We are at the top right corner, which is 2. It says 2. Is that how this works? 0. It should have been 3. Look in the code. 0, 1, 2 is east-south. West-south is the top right corner. But... when we passed the corners of this, we passed 11, 6, 16, 6. That's not a real coordinate. This is the problem. We passed a non-real coordinate. Like, that's in an alternate dimension, when it shouldn't be. Right. I'm having a lot of trouble, like, just navigating the structure, remembering enough to even know where I want to go in the code. We passed non-real coordinate to what? To nearest tile. It was our coordinate list for this. All right. So for the nearest corner assumes that you are describing the box from its lowest left corner. That's our problem. That's our problem. And so we're describing it incorrectly when we recall from in plant area here, start X, start Y, width, height has been futzed with since it came to us. We need... because we already did a nearest corner operation and we repopulated over our old values. That's our problem. So we need the old S. What? I need the old X. Old Y is equal to start X, start Y. This is just the easiest way at the end of the day to whang it in there. And then at the end here, width and height will never change, but X and Y are like that. And then we're describing the area that we want to plant correctly. Like, we were just literally redescribing our area wrong. Because we'd already futzed it with it and made it multi-dimensional. Now everything works. Woo! And that was a 7-hour coding live stream. Holy hell. Holy hell. Let's just sit here and watch and savor. Savor the flavor. What's unfortunate is that now I'm no longer using the, what's it called? The Raster operation, named after a guy whose name starts with the Bresenham rasterized linear algorithm, because we never travel on a diagonal now. I mean, maybe we do, to go from one, you know, from here to, you know, in the back, kind of a thing. But we don't get to see it, like, diagonaling along. The next thing that would be to do with this, like, system of movement would be to optimize it. So that it doesn't hang whenever it has to make a decision on where to go next. But I am happy that we, like, came up with this system anyway. This is what we're trying to prove that still works. Now, when we check this pumpkin, it pops it, it knows where it is in the corner, and it immediately replants. And it immediately finds the quickest way to get to that one. This is brilliant. This one's going to actually have to travel a little bit to get to that guy. I just love how clever it is. Like, over time, it's going to continue iterating in weirder, like, movement patterns. Weirder and weirder movement patterns. Depending on whether it harvested and in what direction and stuff. This is so cool. But it always finds the shortest path to the next job. That's what we wrote today. 6 hours, and it always finds a path to the shortest job. The next step up to this would be to just, like, bring in some kind of A-star pathfinding. Which, if you've never heard of it, A-star is what's used on, like, a grid to determine, like, the fastest way to get to something, even when there are obstacles in the path. So most, like, simple pathfinding algorithms use A-star to determine, okay, if I gotta go from here to here, then, and there's a block in the way, then what's the fastest, you know, how do I travel along the grid in order to get there? It's basically Bresenham on steroids, for finding the linear path via a grid around other obstacles and stuff. But A-star probably has some, you know, thoughtful, clever, shortcuts. Or, you know, just in its general application probably has a shortcut that, that wouldn't have me having to check every alternate dimension. I mean, that's the thing, though. We do have to check these alternate dimensions to see what's the fastest way. Travel across the Pac-Man border. This has been fun, says Elgavo. I'm glad that, that you guys were here and you enjoyed it. Unlicensed streamer, too, in particular. You guys seemed psyched, geeked. It's impressive. And then it stops and has to think for a second. Love that I've overwhelmed this with my convoluted Python code. We have reached arbitrary code execution. We have ace. We have ace. That was fun. I haven't done anything with, like, pathfinding, but I've been working on, you know, images. it's a work of art that expresses my mind right now because of what I've been working on, which I will show you. I will show you my library, the current state of my library. There's not much to see. It is time to split and call it an end of a live stream kind of thing. We're so close to 1 million though. We have 997,500. How quickly are they going up? We might want to sit here to just get to 1 million pumpkins. There might be like a Steam unlock for getting to 1 million pumpkins. Who knows? I need to know how many we get each pop. We've hit 1 million pumpkins. 1 million pumpkins. 1,956,000. What a nice round figure we had right before we hit the million, too. What are the odds of that? Because, I mean, it's immediately not a round number. So it hasn't been round numbers the whole way up. Cool. That's a landmark. That's a landmark. Alright. Let's get the hell out of here. I'm gonna save. I'm gonna quit. I'm gonna save again. And, I'm gonna show you my code. So, let me just close down my pornography. The things I don't want you to see anyway. Let me just close down the things that need not be seen by the likes of man nor you. Which implies that you're not man. And then bring you over to the coding workspace. Is the coding workspace still functional? I don't think it will have a webcam. Coding. No webcam. Webcam! Hey. Where the hell would I sit, though, in the coding web space? Probably down here. And then, like, 20 pixels in from the left. Maybe that's it. Okay. So, coding workspace, I need PyCharm. This is my actual desktop. This isn't the fake one. But we are set up in a way for, you know, coding on the live stream. Update my skeletons. Thank you, baby. Yeah. Don't forget to discover my whatever else. This is the state of my code as of today. This is my GUIable system. It is a TK Enter wrapper. It is trying to hide everything that's wrong with TK Enter, but the main thing about it is that it brings in transparency. It makes absolutely everything into a canvas, so it gets drawn. And that means that you can skin everything in TK using my library. You can put a skin on everything, and that skin can be transparent, and it'll see through to the background underneath it, as I demonstrate when I move this guy around, and he sees through to the objects that are underneath him, and shows the objects that are above him. TK doesn't do this. TK does not support transparency like this. I am faking it. I am faking the transparency. By copying in layers. This is a square. If you could see this, like, it is as square as this is, right? It is a square that is being, the background is being copied to it, and then any object that's underneath it is being copied to its surface, and then it is being copied to its surface above that. It's not all happening in layers. It's all happening in a clever way where we composite to a base layer, and then we copy from that base layer as we go through the stages. When we pass underneath something, we copy the background right to our base layer, then we copy ourselves to the base layer, and then we copy the base layer to ourselves, the base layer that has the version of ourselves on it, and then we copy the things that are above us to the base layer, and then we copy the base layer back to the things that are above us. But we only do it in the square that we're updating. So the square is exactly the size of this, and the last place that it was in. And what you'll see when I'm moving this thing around, on the right there, Is that correct? Yeah, on the right there, you see my how long it takes to do a draw. 0.0002 some seconds, less than 300,000ths of a second is how long it takes on average to draw. And that is a fucking amazing. I just figured out how to get that level of performance out of this guy. And I don't even want to get into it trying to explain it. It's been too long of a live stream. But so yeah, this look, you can drag it around, and we're on the live stream, by the way, too, so that reduces how fast any of this can happen. And it's still taking less than 300,000ths of a second. It's more like 200,000ths of a second when we're not on the live stream. But so I've also made all of these objects. So this is supposed to be a checkbox. You can see again in the output there, toggle state equals true now. Now it's false. Now that one's false. Now this one's true. These ones don't output anything because these are actually linked to the scroll area that we've got over here. And these are the things that work in the scroll area. We've got line scrolling. We've got page scrolling, where you click and in a page, it moves everything. You can click and drag and it'll chase you. We've got another version of scrolling. When I middle mouse click, we just go immediately to the section of the page that is represented by the scroll bar. Middle mouse click, just boom, goes immediately to the end, immediately to the middle, immediately to there, and it will also chase your cursor as you drag. We've got one of these in here to show that if I move something in the scroll area and then I go off screen, when I come back, it is where I left it. Because all of these things are actually, once they go off screen, they're not being considered anymore. They're not being handled. So it's when they return to the screen space, they have to find the place that they were at last. And we also have mouse wheel scrolling, which is what you're seeing me do there. So from here, a full mouse wheel scroll goes down to there. And it doesn't matter how fast or slow I do it. There's a lot of ways you can implement this that are wrong and that will matter. If you drag slowly, we get to 14. But if you drag fast, we get to 14 still in my code, because I've done it the right way. You can also obviously drag the handle and just move everything that way. And you can see that it's a little sketch because of how many things that it's having to update at once and how many things it's having to draw the background of. Like at the bottom there, you see little flashes of where the background isn't being redrawn fast enough as things are moving up. That's because we're moving every single one of these things individually. The good news is that at 2 to 3 100,000ths of a second, you can be moving between 50 and 75 objects on the screen at once before we're moving more objects than are in a 65 frame per second update cycle. But yeah, that's basically, so not a lot has changed. I've also got a completely invisible draggable widget over here. It just has no skin on it whatsoever, just to prove that that invisibility is, our transparency is working in all cases. And you can see how sometimes there's a little bit of a delay. You can see a little wobble in, it redrawing. Makes absolutely no difference to your average user interface that there's a slight wobble when you really try and force it like that. And again, the performance is better on the live stream. The fact that it comes over everything, it does not draw the scroll bar for reasons that are complicated, and I again don't want to explain. It's been a long day. But yeah, this is what I've been working on for the past 3 months. I'm trying to push a release by November. I'm not sure if I'm going to hit that goal or not, but we will see. Oh, I said these are attached to the scroll window. When I click on here, we're no longer smoothing the scroll. So now it just does the scroll that you request. Page scroll, page scroll, page scroll. But it doesn't smooth it. It doesn't animate the in-between steps when you turn that off. This button over here, I will left click and we'll see that does a page scroll, page scroll, page scroll. If I turn this on and I do a left click, it does an instant scroll where it just goes immediately to the mouse. And now if I click middle mouse, we do a page scroll. So this shows that you can flip which button does what. That's what I left that one in there for. And then these, example, different kinds of buttons, a button that you can hold and it will repeat, a button that when you click it, it instantly clicks, as opposed to a button where when you click it, nothing happens until you release over top of it, which is how most buttons work. That's the state of my code as of today. And thank you for joining me on my Python adventure. That library I'm working on is called GUIable. I am on GitHub with it. I'm developing in a non-master branch called GUIable 2. If you want to look at my actual code and see the latest update that nearly doubled the performance. But the most important thing to remember from everything that happened today, what you want to have learned in all of our Python coding, is that I am the Ronin pawn. And I hope to see you back here this Sunday, which is when our next live stream will be. Unless I get, really, I'm not going to sit down and watch this whole 7-hour live stream back after having performed this but if I get really antsy, I don't know, we might do Farmer Was Replaced. I want to do some Cluster Truck. I've been working on a new trick. I mean, I was doing it before, but I've gotten so much better at it. The 910 grappling hook trick. I'd like to show that off, and I'd like to start doing full runs of no utility, no pause skip. It's just up to other games to stop being so interesting, and then we'll be able to get back to boring old Cluster Truck. The other thing that I would have liked to talk about today that we didn't get around to is Chess Texas. I've been playing a new chess game that I saw the Game Grumps play. I was like, that might make chess approachable for me to actually play it, and it has. And I've played some interesting games against bots that I have saved to chess.com. And I would love to share those with you, too, on another day, perhaps this Sunday at 2 p.m. U.S. Eastern Time, for I am the Ronin Pawn. Now get the hell out of here, Pawn out.